you can do this while also keeping operation in mind. And so the goal is to go from what you see on the left and go to what you see on the right. So to start out for my methodology, I wanted to talk about the participants. So I'm recruiting students, staff, faculty, and am hoping for 60 participants total. And then I also have some exclusion criteria. So any participants that are taking medication for stress and anxiety will be excluded, and also if they've done some extensive exercise or have smoked or drank alcohol within 6 hours of the study. And so for my methodology, I'm kind of splitting this up into 3 parts. So first, we're going to do the demographic questionnaire and the informed consent. I'll include some example questions here in a little bit, and then we're going to have participants randomly assigned to 1 to 3 virtual conditions. Condition 1 is a hospital room with no biophilia. Condition 2 has 1 single biophilic element, which would be plants. And then condition 3 will be a combination of what we would see, natural materials, plants, and then views of the outdoors. And then following their exposure, they'll be able to answer and go through a few post questionnaires regarding their satisfaction, pleasure, stress, and then the NASA TLX. So for the instruments used, I wanted to go ahead and list that. So first, a demographic questionnaire, and then while they're in the virtual environment, I'm going to be using eye tracking to measure their cognitive load and look at their pupil dilation. And while they're within the environment, I'm also going to be taking, looking at their skin conductance levels and their heart rate. And so prior to their exposure, I will have them rest with their eyes closed for 3 minutes so I can get their baseline measurements. And then afterwards, they will be answering those questionnaires. And so just to show an examples of the rooms that they're going to be randomly experiencing, condition 1 is the one with no biophilia. Condition 2, you can see has the inclusion of plants. And then condition 3, you can see that they have the views of nature, the plants, and the natural materials with the wood. So for some example questions, for the demographic, it's kind of going to be asking them if they like natural spaces in general, and if they've had good sleep, because those are some things to consider when looking at the results. For the satisfaction, I'm going to look whether or not they felt safe within the environment and if they were happy with the existing elements within the space. And then for the NASA TLX, it's going to be asking how successful they think they were in accomplishing the goals of the task, and if they felt insecure or discouraged while they were participating. Next, I'm looking at the self-assessment mannequin, which has participants kind of choose how they feel based on each row, based on pleasure, arousal, and dominance. And then for the stress level questionnaire, it's going to ask them stuff if they found it hard to be relaxed within the space, and if they could rate their level of stress whenever they experience the space. For my anticipated results, I anticipate that participants will prefer conditions 2 and 3 over condition 1. Overall, I think condition 3 is going to be the most preferred, and we'll see the biggest reduction in cognitive load and stress overall within condition 3. And then this is just my theoretical framework from, and this is how I've gathered all my hypotheses and what I'm going to be testing while doing my research. And for some implications, additional research on the use of biophilic design in healthcare could influence the way these spaces are designed to a new hospital setting that improves overall patient satisfaction. And hopefully in the future, maybe this can branch out to, look at the employees of the space or the caregivers and their families who are coming in. And these are just my references.
Good morning, everyone. So my name is Thao-Nguyen Bach. I'm currently a student from the University of Texas at Dallas. And today is my pleasure to introduce you to our little project. This is a correlative image analysis of the inter-morphogenetic domain signaling network regulating C. elegans embryogenesis. It's a mouthful, but let's dissect it together. So in this project, rather than targeting a specific cell or an individual gene and find out what happened to the overall phenotype, and here we actually aim to understand the collective cellular behavior and the signaling between cell population, because the coordination between signaling pathway is crucial in all biological processes. Here we pick C. elegans embryo development as a model for various reasons. The first reason, as you can see on your right here, is that the timeline of the embryo development is very short in comparison with other organisms. So it's convenient when we generate data. Another reason is that this model is very robust because it had invariant lineage. So what that means is that the pattern of cell division, apoptosis, and terminal differentiation are constant from one embryo to another embryo, of course, like under the same control environment. And lastly, is it because it has beautiful imaging database, because the organism is transparent. So that's why you can see this beautiful imaging live image right here. Even though C. elegans is a simple model organisms, but during its embryo development, the cells do coordinate with each other and undergo complicated processes like gastrulation, like as you can see in the live image here, and as well as epidermal enclosure. Then the live image here, like it's very clear to see, and the cell coordinate at a systemic level. So it's important to understand the collective cellular behavior. So how do we do this? In order to achieve that, we started with the EPIC database, which measures the gene expression in every single cell with 1 minute time resolution. And they actually measure it in C. elegans embryo up to at least 350 cell states. So 350 cell states is one division before the cell, before the C. elegans actually hatch. So it's like very intense database. And of course, we also use our collaborators for the imaging data. And we process the data in two parallel streams. One is gene expression and the other is cell position. So after performing quality control, normalization, and 4D alignment, as you can see on this side, across the different embryos, we integrated the data together to construct a virtual embryos. And we use this to build a database and train a random forest model to predict cell position. So let's go into the detail of our work. So here is a snapshot of our virtual embryo at 345 cell stage. Because of the high risk of technical issue when embedding video in this talk, so I chose not to do that. But if you are interested, please contact us. I have our contact information on the last slide as well. Please stay tuned. So below this is our gene expression heat map. So FAR4 is a marker for the pharynx and the intestine in C. elegans. So that's why you can see it's in the middle of the embryos here, because it's the digestive tract. On your right-hand side is our result of the random forest models that we predict cell position. So the y-axis is predicted cell position, the x-axis is the observed. And we did this for along the three body axis, ventral dorsal, so that VD, LR is left and right axis, AP is anterior posterior axis. So you can see a really high correlation between the predicted and the observed cell position. In comparison with the first plot, that is our negative control, which we predict the cell position based on randomly generated gene expression. So then what we can do with all of this, right? So first of all, it is an imaging database. So here we use that database to investigate the collective cellular behavior. Because in C. elegans, when we know the cell identity, we can assign the anatomical labels based on the invariant cell lineage. So on your left is two examples. On the top is the muscular tissue right here. At the bottom is the intestine as an organ. So from our database, we can observe how intestine is formed over time in these 3D embryos. On your right-hand side is the color-coded anatomical labels. So like neuron, hypodermis, and so on, and different viewing angles. So here we can study the anatomical pattern and how it changes in 2D slicing. So we can examine a fixed spatial slide and study how it changes over time, like on this first row and the second row right here. Another way we can study this is that we can fix the time point and study across the body axis, like across the AP axis, LR axis, or ventral dorsal axis as well. So this is the first layer of our information in our database, the anatomical pattern. The second layer is the gene expression. So similarly, we can also observe the changes across the space and across the time. In total, we generated more than 5 million in silico histology sectioning gene expression pattern images. So along the 3 body axis and across a time step. So that is a huge source for training predictive model for future study. We also extracted the feature from our images and by doing principal component analysis, and we use them to cluster and identify 20 distinct gene expression pattern, which we refer to as morphogenetic domain. And so each of these domains are the spatial expression pattern of a group of gene, and yellow mean high expression and blue mean 0, no expression at all. So lastly, with those domains, we perform correlative image analysis by superimposing that with the anatomical pattern images that we presented earlier. So for each of the cluster, we identify the signaling pathway that regulate the tissue boundary formation through gene ontology analysis. So an example I'm showing here is 2 signaling pathways that are very well known, that is afferent and NOS signaling in the AP axis of the middle body part. And through individual gene mutation study, we know that afferent plays a huge role in cell-cell interaction during epidermal morphogenesis, which is required for the neuron cell to interact with the epidermal cell. In later developmental stages, it's known for axon guidance. On the other hand, NOS signaling is known for cell phase specification in early embryo development. And in 2016, there is a study that found its role in a later embryo development stage during the digestive tube development. But here, rather than targeting a specific component of a signaling pathway or is present in a particular cell or cell lineage, we are showing you the landscape of the signaling pathway and the potential crosstalk across different domains. So besides NOS and afferent, we also have other like signaling pathway, like Wnt signaling pathway as well. So in conclusion, in this study, we established a virtual reference embryos. We created an image database that have both gene expression pattern and the anatomical patterns of the virtual embryos. And this can be used to train various machine learning models. We show you one example that predict the cell position from gene expression that have really high accuracy. And then lastly, we perform correlative image analysis to study signaling landscape across different domains. So this emphasizes the role of data in biological study and how we can enhance our understanding of biological systems by examining the data from different angles of it. And lastly, I would like to thank every member of my lab, my PI and Dr. Benio for leading the project, and of course the suggestion from other members of the lab. And I would like to give a shout out to Kathy. She will have her presentation in this afternoon. Please stay tuned for her. Her talk going to be about oncology. You will love it. And of course, I would like to thank our collaborator, Dr. Dujo Lab, for their generosity and helping us with our data analysis, as well as Dr. Murray, and the beautiful and high quality data from the EPIC data set. I would also like to thank the people behind the scene, helping us and presenting me with this opportunity for showcasing our research. Thank you so much for the organizer, and thank you everyone. Yeah.
Thank you very much, Thao.
I cannot access the Q&A, so may I ask a question this way?
Oh, sure, yes, yes.
I was wondering if you could talk a little bit about your imaging process there. it was beautiful, and
Thank you.
and I wondered how difficult it is to get those images. Do you need to, what kind of processing goes behind that?
Yes, so first of all, like there was a lot of timing consumption in like quality control in aligning the imaging, because the amount of data is so big. It actually took us like night to do it, because like it's so consuming. So we use like what you call the X species. So we don't want to because our lab we have other member that we use the same cluster, so we don't want to inference with their work. So we normally run our work during the night and submit the job. Yes, it is very time consuming to construct this data. Yes, yes. And there is a lot of analysis running on the background, because there are just so many angles that we can analyze the data. So that's why we do try our best to highlight. So here, my research interest is cell-cell communication. That's why we focus on cell signaling. But at the same time, the database can be used for other research as well, other purposes for, new student coming in if they're interested, so they can do that. But yes, it is time consuming, computational consuming. Yes.
What I'm going to talk to you about today, and I'm going to pose a question that, I'd like you to reflect on if you're interested in it, is, does science self-correct? So we talk a lot about data, we talk a lot about open. I know that there's been some really interesting discussions at this meeting about those issues. And I think that, it's all in this with the understanding, or at least the assumption or hope that expectation that science self-corrects when someone finds a problem, or when someone finds an issue. And, does it really? And if it does, how effective and how efficient is that process? And so that's kind of my guiding question here. And I'm going to put that in the context of COVID-19. Obviously, we're in the midst of that, which is why, of course, we can't all be there in person. But none of these issues started with the pandemic. They are far more than a year old. And that's why I sort of think about, cancer just as one particular subject, which is studied by a lot of researchers, but sort of thinking a little bit about from cancer to COVID-19, does science self-correct? So at the risk of showing you my picture twice, which I think once is generally more than enough. The reason I'm forcing you, or at least you can look away, but the reason why I've put my picture on this slide here to begin is to paint a picture a little bit of where journals are and what sorts of issues they're dealing with and what we're all dealing with. So as the headline of this Retraction Watch post says, Elsevier journals, 5 different journals actually, asked me as I guess the co-founder of Retraction Watch, but to peer review different COVID papers about COVID-19. Now, I didn't get into all of my degrees and credentials and experience, but maybe I'd ask you to believe me when I say that I'm not an expert in COVID-19. I am maybe an expert in retractions, but that's about it. Now, however, these journals, they are desperate for reviewers. They are looking anywhere. They try and, look in all the cushions for all the loose change of reviewers. And so they ended up with me. How did they end up with me? Well, as best I can tell, it's because I co-authored with Adam Marcus, my co-founder, and with Allison Howard, our researcher at Retraction Watch, a letter to the editor, which I'm actually going to show you on the next slide, of about 4 paragraphs that was about COVID-19 retractions. And it was a letter to the editor in response to something else, which I'll talk about in a second. But that is the sum total of my expertise in COVID-19. And yet, because editors are being deluged with papers, and this, by the way, was just in February and March, so it's not like it was the beginning of the pandemic or even the middle of it. We're a year into it by now. An algorithm picked me out of a database and said, yeah, here's a guy who apparently has published about COVID-19, so you should invite him to review. Now, in and of itself, algorithms are going to algorithm, as I wrote in the post. On the other hand, it means that I can't imagine that those editors actually looked at who they were inviting. My name is, well, at least known to editors. And frankly, even if it wasn't known to editors, even worse, look me up, see who I am, and why on earth you're asking me to peer review a paper on COVID-19. By the way, I turned them all down just in case you were thinking that, I'm part of the problem, and maybe I am part of the problem, but not in that way. So that's what we're dealing with. And so how can we expect, if journals are so desperate as to be asking me to peer review papers about COVID-19, that they are doing a great job, in terms of peer review, in terms of, again, correcting whatever the record is. So question for you, and there we go. Oops. Okay. So, now the flip side of this is once things are published, what's actually going on? And in fact, there have been 121 retractions of COVID-19 papers. We keep track of those. We keep track of retractions in general, as I'll get to in a little while. And so 121 retractions, and that sounds like a lot. It's a decent sized number. I can tell you that it's more retractions than there were in the entire literature 20 years ago by an order of, not an order of magnitude, but by a multiple of 3. There were only about 40 retractions in the year 2000. And yet, is it actually a big number? Well, I don't know yet. I'm going to get to that on the next slide. But again, you can go, this is a openly available page on our site. We actually update it pretty regularly. Having given talks on this subject frequently over the past couple of months, I can tell you that, when I use a slide like this, it basically has to get updated every single time. And in fact, there were 26 of these retractions all at once about 2 weeks ago for some sort of strange reasons. But, again, what does it really mean? And the question is it really a higher number? Now, the letter that I mentioned we wrote was in response to a piece in Accountability and Research, one of the journals published by Thao and Francis, that claimed that this was an alarming and exceptionally high rate of COVID-19 retractions. Now, I'm not actually sure that's the case, because if you look at the denominator, which a lot of people, you'll forgive me, sort of tend to forget when they look at retractions, because they see these numbers and they just get really, oh my goodness, what is going on here? Well, if you look at the denominator, depending on which data set you're looking at, it's clearly well over 100,000 papers. And that includes, by the way, preprints, because we include preprints among withdrawals when they're withdrawn. So that's part of that 121 figure. And when you boil down the numbers, essentially the rate of retraction is about what you would expect for the literature writ large. It's about 410,000 is the overall rate. The difference, there are two differences. One is that these are happening much more quickly than normal. And this is actually sort of a sub-theme, if you will, of my talk, which is how long retractions normally take. So these have all happened essentially within a year, right? I mean, nobody's publishing about COVID-19. I think the first paper probably appeared in February, maybe January. So all these retractions are happening within a year. Most of the time, retractions take more like 3 years on average. But the other reason, the other difference that we've seen, and it's almost certainly related, is that these retractions are not for the typical reasons you see retractions. Some of them are. There's been some plagiarism and what have you, but most of them are not for misconduct, or at least according to the retraction notices, they're not for misconduct. Now, and that could explain why some of them are happening more quickly. The ones that are for misconduct typically take longer. So again, we just don't really know, but I think that drawing any conclusions, if we're being evidence-based and scientific about it, is problematic. And I say, let's wait a few years to see what exactly happens. So there's clearly something happening. There are many things that are unprecedented about this pandemic. The rate of retraction may not be one of them. And in fact, what I'm going to argue, I think today, is that a lot of what we've seen during the pandemic is simply an expansion, an exacerbation, an acceleration of trends that we've already seen before. Why is that happening? I don't think I have to tell anyone that we are compressing, a marathon into a 400-meter dash, as Jackie Flynn Mogensen wrote in Mother Jones last year. So we have, look, I was thrilled to be able to get my first dose of vaccine a week ago today. I'm going to get my next one, I guess 3 weeks from now. And I'm thrilled about that. I can't tell you how excited I am to, get out of my house on a more regular basis and, go back to my office. Or actually it's a new office because I have a new job in the middle of the pandemic, but what have you, go to my office, teach in person. I mean, I think it's actually been working pretty well to teach remotely, but I think it'll go even better once we're back and you can have all people around you. And it's who we are. We're social creatures. And so, and if you would ask me, did I expect there to be a vaccine? If you would ask me a year ago, you think there'll be a vaccine, you think it'll be, signing up to get a shot, in April of 2021, I would have said, no, probably not, because that's just really fast for vaccines. And yet, so it's great, right? In fact, that, we've seen this acceleration and this sort of speeding up. I mean, that's a positive. On the other hand, what happens when you rush? Not everything is good. And a lot of things that, maybe shouldn't have seen the light of day, or that, are going to turn out to be wrong, they just kind of get thrown out there anyway. People publish, then journalists write about them, and all sorts of things happen. So that's really what we're dealing with. And so just look very close, like, in a very specific way at journals, what's happening there. This is a paper that came out back in June of last year. The median time for receipt, and this is for papers about COVID-19, from median time from receipt to acceptance is 6 days. Now, those of you who've been involved in peer review or getting involved in peer review, or maybe you're journal editors or journal editorial board members, getting people to even accept an an invitation, say yes to an invitation to peer review a paper in 6 days is kind of impressive. But to get a review back and actually have a paper accepted within 6 days is pretty remarkable. And yet that's what's happening. And I guess I would challenge, or I would at least have you all who are involved in peer review ask yourselves whether, you think that necessarily means you're going to be able to have the same quality assurance checks. And I think, again, we don't know yet whether retractions will be higher or lower, but they're only a mark of what people notice, not a mark of what's actually in the literature, and maybe shouldn't be. I'd sort of, again, and if part of that is because they're asking so many more people, some of whom, like me, do not have the requisite experience, again, how is that like a positive? Adam, I mentioned Adam Marcus, he's my co-founder at Retraction Watch. He and I wrote a bunch of times last year for Wired, and this is one of those pieces. And the point is that, getting, we all get there, and the science is getting there, which is great, but people are rushing, and any particular study is not necessarily going to, tell us what we want to know, or even be well, certainly not the whole truth, but it may not even be true. It may be a sort of very, specific bit of information that doesn't actually help us. But one thing I would sort of think about is, how different is this actually? How different is this time that we're living in? And how different is it? People last year, the narrative seemed to be for a lot of the year, well, it's dramatically different time, and we clearly, we have so much to learn from this. We definitely do have a lot to learn from this, but it is not as though this was the first time that there had ever been a retraction. It's not as though it's the first time there had been a retraction in New England Journal of Medicine or The Lancet, which were two of the major journals that published papers and had to retract them in a very high profile way, like front page of New York Times way, last May and June. And so, they are the very same journals that have published other papers have been retracted. You all will recall, unfortunately, the paper by Andrew Wakefield in 1998 claiming that vaccines were linked to autism, right? We're still living with that. In fact, you could even argue there's a direct line from some of the vaccine hesitancy that we see now and that paper, which, by the way, The Lancet took 12 years to retract. So you're dealing here with things that have happened before. They're happening on a larger scale. They're happening more quickly, perhaps. But let's not, what I would urge everyone to at least consider not doing is, allowing this to be, everything's unprecedented. We've never seen anything like it, sort of isolating it at this time instead of saying it has revealed a lot of the deep flaws. It's like when the tide comes in and out, it has revealed a lot of the deep flaws that we've known about for a long time. And in fact, lots of people are trying to work on, but we need to continue working on. So let me sort of take you a little bit back in history, about 10 years now, 10 and a half years ago now, to why Adam and I launched Retraction Watch to begin with. And again, to give you a sense of what we knew then, and we meaning not just me and Adam, but everyone sort of working in science and publishing and academia, and sort of what we know now, which I'm going to get to in a minute. But Adam had broken a big story of someone named Scott Rubin. Scott Rubin was a anesthesiologist, sort of pain researcher, pain management researcher. And he was studying something called Celebrex, celecoxib, which was one of the, you may remember Vioxx and Celebrex. These are drugs. Celebrex is still on the market, but with a black box warning. Vioxx is no longer on the market. And these were supposed to be, I'm going to give this very, oversimplified version of the story, but these were supposed to be better painkillers. They were supposed to have a lot fewer side effects than sort of typical painkillers that targeted that pathway, right? So long story short, they may have been better painkillers, although that's not clear, but they also led to increased heart attacks, which is obviously not a good thing for pain or for any drug, let alone painkillers. So, but Scott Rubin was doing a bunch of research that was important in this field and very well thought of and all of that, well cited. But there was just one problem. And the problem turned out to be that he was making up all the results in his studies. He was making up all the patients. They were all fake. And so, well, that obviously once it became known, he ended up having 25 retractions, much more to the point. He ended up going to federal prison for charges related to scientific misconduct. Very rare, but it happens. And Adam, because he was editor-in-chief at the time of something called Anesthesiology News, the magazine for people who put other people to sleep, although for some reason they don't use that tagline. He broke this story, which was, became international news. I had known Adam a little bit through sort of being both medical journalists and was in touch with him about this. I had thought about retractions a little bit over the years, but not much. But what this made me realize, sort of, hit me in the face with was, there are a lot of great stories hiding in plain sight in these retractions. And, wouldn't that be interesting to sort of actually look for all those in a targeted way? And when we looked at the retraction notices together, we noticed that they were often misleading. They didn't include all the right information, or they didn't include any information. We thought that's a problem for science. It's a transparency problem for science. So I said, hey, let's start a blog. And Adam said, sure, whatever, let's start a blog. And there, we started a blog. We had no idea. It's not that we had no idea what we were doing. We had no idea what the scale of the issue was. So I mentioned that there were about 40 retractions in the year 2000. That's, and we were in 2010. We actually figured there were still about 40 retractions. And nobody, including us, had checked. It turns out that there were about 400 retractions that year from scientific journals, many more than that if you include conference abstract retractions and withdrawals. And so, well, maybe had we known, we might not have launched it because we would have known that we couldn't keep up right away, but I like to think we still would have. But what that led us to was realizing we couldn't keep up, in fact. We could not write about every single one. If there are 40 retractions a year, and there are two of us, and this is, again, a side volunteer project, but even so, it's fun. So, each of us writing a few times a month to keep up with retractions and do some reporting on each one, that's manageable and all that. But clearly, immediately, it became clear that we could not do that. We could not keep up. And so, sort of several years elapsed before this all happened. But by 2014, it was clear that the world needed we thought anyway, a database of retractions, because these were not available in the usual sources like PubMed and Crossref and Web of Science. Sometimes because those indices just don't include everything, but a lot of the time it's because publishers were not providing the right information. They were not providing the right metadata to these indices. So, and as you'll see, that leads to a number of problems. So we said, well, here's the one thing we know about is retraction. So we're going to create a database. And this has been live since end of 2018. I'll show you a little bit of data from it and some findings. And we have a full-time researcher who works on this. We actually have more than 25,000 retractions in it now. It's the most comprehensive database of retractions anywhere. And in fact, we also have reasons for retraction. This is just a screenshot. You can see reasons for retraction in each of these, for each of the retractions. And so that's something that we include that no one else includes either. You can go there, retractiondatabase.org, search however you'd like, and check it out. But one of the things that we, again, quickly saw was that retraction rates had been rising. Now, this says retraction rates leveling off, potentially. This, again, was from a piece of journalism that Science did with our collaboration when we officially launched the database in late 2018. But basically, retractions grew. They went from, again, about 40 to, well, this past year in 2020, there were 2,200. Now, the rate of papers has also increased, right? So probably 4 or 5, maybe 6 times in that span, but it hasn't increased 50 times, which is what 40 to 2,200, 54 times actually. 55 times, anyway, 50 something times. And so, you know, that means something's happening. And so what we are pretty sure is happening is that more people are watching for retractions and watching for problematic issues, which I will get to in a moment. I'll show you who some of those people are. There may be there's some slight evidence that misconduct itself, which is responsible for a lot of retractions, is on the rise. But clearly, you know, the rate now is about 4 in 10,000, as I mentioned. You can ignore the leveling off. The leveling off, I think, actually isn't even true anymore either. But before these retractions take a while, it's hard to tell what's actually happening for a few years, which is why there's that dotted line, like looking at, you know, sort of future performance of a stock or something. It's not all that useful. In fact, it shouldn't really be declining. It's definitely not declining. So looking at that, you know, I'll tell you, I'll just flip through here these are some common reasons for retractions. You know, again, as I mentioned, and on the next slide, you'll see this in a little bit more graphical form. About, you know, 2/3 of the time, retractions are due to something that would be considered misconduct. In a lot of these cases, as you see, duplication, plagiarism, image manipulation, these are all misconduct. Image manipulation, that's what we see a lot, is sort of Western blots, people working in basic science labs. They, you know, maybe they didn't run a control lane, so they add one, they just sort of Photoshop it in, or there's a you know, a band that doesn't look right, so they Photoshop that out, in or out. Sometimes people just duplicate an image from an old study that looks like what they want to show. That's misconduct. So that's a reason for retraction. One of my still favorite stories, and we've been reporting on this for 10 years now, is fake peer review. So this is responsible for about 1,000 retractions in our database of 25,000. This is when you manage to peer review your own paper. So now I'm sure that all of you are thinking, wow, that's awesome. I'd love to do that. Tell me how. I'm going to tell you how, but I'm going to preface that by saying don't do it because it's wrong, and also because you'll probably get caught at this stage. But this is when you actually, somebody, you know, you're asked by a journal to submit potential peer reviewers. You submit potential peer reviewers, and you submit a real person's name, you know, but instead of that person's real email address, you made up an email address, you know, at Gmail. And then you end up getting, the editor invites that person without looking at the email address. That part is where you get caught now, because journal editors now are basically forced to look at that. But, you know, that's pretty great. And then you get to peer review your own paper. Again, don't do that, but that's responsible. You know, when you think about the level of ingenuity that required, you sort of wish that people had applied that to science, as you know, to research, as opposed to, I don't know, criminal behavior, which that kind of is. It's at least pretty bad behavior. Anyway, still one of our favorite stories. I want to look just, again, there's some other ones. Publisher error, not terribly important, but it's, you know, one of these annoying things where publishers, and it's not the author's fault, it's the publisher's fault. They publish the same paper twice, and somehow the only way they know how to deal with that is to have a retraction. So they have a retraction in your CV. Kind of annoying. And in fact, it is what is responsible for more than a dozen, I think, of the current retractions for COVID-19. So again, showing you the rushing without there being anything wrong with the paper or without there being any misconduct. Authorship issues. Now, the serious part of this is that these are a huge headache. And so this is when, you know, there are authors who should be on papers who aren't. There's authors who shouldn't be on papers who are. There's sort of this concept of honorary or guest authorship, right? And so, you know, this is something that it's just a huge headache. And how do you decide who should be on? And what, there are guidelines for this, but it becomes a problem. And then there are some fun issues, which again, just to be clear, I do not think should be retracted, any of these papers I'm about to mention. But there was there still is, but she's retired now, a very well-known immunologist named Polly Matzinger. And long story short, she did not like using the passive voice in her papers. And she also did the work by herself. So she would say, I did this, I did that, I did that. And the editors would say, oh, this is great, you know, really interesting finding. We want to publish it, but, you know, we don't do the I in science, you know, we do the royal we or the passive voice. She said, I don't want to do that. And so they went back and forth. She finally got sick of it. What did she do? She started adding an author so she could say, we did this, we did that. Now, the name of the author was, and you can look this up in PubMed, still exists, Galadriel Mirkwood. Now, if you look up Galadriel Mirkwood, in Google, what you'll find out is a Galadriel Mirkwood is the name of a Monty Python character, also the name of Polly Matzinger's Afghan Hound, who I am fairly sure has passed away now because this was in the 70s and 80s. And I don't know if you've ever tried to train a dog of any kind to work in the lab. If you have and you've been successful, you should probably write that up and maybe even make a career out of it. Better than Cesar Millan, but I'm reasonably sure, of course, and she was just making a point here, right? And should it be retracted? Of course not. I mean, what's the worst that could happen? Galadriel Mirkwood, somebody uses that name and applies for a position somewhere, and someone says, "Oh, look at this! You've published all these papers." Well, that's obviously not going to happen. And frankly, the joke is on whoever hires that person if they really didn't do any due diligence. It was a widely known story, but the point is that shouldn't be retracted. I think it actually is a brilliant way to sort of send up what's really going on with some writing and some publishing. But the serious authorship issues, those can really become a headache. And just I would point that out. Finally, I would just say legal reasons. Lawyers get involved in all these cases. Not in all of them, some of them, a large number of them. We actually have this is sort of the opposite of what I'm describing, but just yesterday we reported on a lawsuit against the American Society of Anesthesiology and the number of authors of papers because a company didn't like what they said about their product. They only have one product. And so they're suing them. They're suing for retraction. They're suing all sorts of ways. But there are other lawyers who, defend people who are found either alleged to have committed misconduct or found to have committed misconduct. What that means is that a lot of the scientific record is very murky. It's lawyers try and make their clients look as good as possible or not as bad as possible. And so everything takes longer and the retraction notices are often unclear. So again, not great for science when that happens, but it is important to think about the fact that lawyers are involved in some of these cases. And those of you who may work, I know that some of you work in offices of research integrity and similar offices, that you know that. I don't have to tell you that. And then finally, not reproducible. This is not actually a sort of typical reason for retraction. And in fact, if it was, then most paper, not most, but many millions of papers would probably have to be retracted. But some authors have just decided to do this and sort of come forward about something they found later on where something wasn't reproducible. But again, that's probably not the best way to deal with. Retractions are probably not the best way to deal with that. If there was a clear error, like they used the wrong reagent, they made a wrong calculation, they didn't realize something about the test, or there was misconduct, which somebody found. Those are real, yes, those will all turn out to be not reproducible too, but there's at least an explanation for it. And according to Committee on Publication Ethics guidelines, that's a legitimate reason for retraction. But just something being not reproducible, anyway, it's an interesting point of discussion, if nothing else, but some small number of researchers have started retracting for that. I mentioned briefly that about 2/3 of retractions are due to misconduct. This is again from the science piece that I mentioned. And you can see here graphically that, if you consider fraud, other misconduct, possible misconduct, that's responsible, depending on how you count it, from 60 to 67% of retractions. And this is back in 2018. Nobody's run this since, and we'd be happy for them too, but I think it would track roughly the same. But remember, I said that, most of the retractions for COVID-19 papers have not been any of those reasons, which is sort of interesting. Again, we might sort of learn something from that moving forward. But one of the issues, and this is sort of, I think, to me, gets to the question of whether it really gets to the central part of the question of does science self-correct, is how long all these things take. These are headlines from Retraction Watch. One, or 6 years, 2 years, 3 years. The top one is just when someone, Elizabeth Bick, who you'll hear about again in a moment, when she flagged an issue for a particular journal, it took 6 years for them to do anything. That's kind of a lot. A couple other the other headlines that you see here, these are actually from our own reporting, where we typically, when we see a public university, which OSU of course is, but a public university that has made a misconduct finding, we will often file a public records request for any correspondence between the university and the journals. Now, these are sort of official letters. These aren't, emails to, private emails or anything else. We're not asking for that. We're asking for official correspondence where the provost or the vice president of research or someone like that writes a letter saying there's been a misconduct finding. We would request that you retract this paper. So you would think that the journals would act on that because it's about as safe as they can be, legally speaking, and what have you. And it's a very official, I mean, universities don't go out and do that willy-nilly. They spend a lot of time and effort doing investigations and what have you. And yet it still takes journals 2 years, almost 3 years in these cases. We're not quite sure we never get a good explanation of why that happens. And often it's, well, sorry, it slipped through the cracks. Well, okay, great to admit that, but that does beg the question, are you really correcting the record? Or are you not making it a priority? And I kind of, unfortunately, think I know the answer to that, but others may disagree. Again, just to give you some more examples of this is a group that has looked at a couple different researchers, sort of body of researchers' work. They wrote to, about 36 different papers. Excuse me, less than half the time that the journals actually, even do anything about it, or at least even communicate a decision about it. Journals are just not, they're just not doing what, and then here they call it slow, opaque, and inconsistent. David Allison, who now is dean at the Indiana School of Public Health, Indiana University School of Public Health, was at University of Alabama, Birmingham at the time. He wrote this with some colleagues, grad students and postdocs. They found serious errors in 24 papers. In only 8 cases did the journals actually write back to them. This was in Nature 5 years ago now. Again, another case of this, I mentioned Elizabeth Bick. She has, again, in this particular, for this paper, which came out, again, also 5 years ago, she looked at 20,000 different papers. She has an uncanny ability, an amazing ability to find problems in images, figure out that they're duplicated, that they're manipulated, rotated, whatever it is. And she went through 20,000 papers, amazing work, found that 4% of them had problematic figures, 2% of them, okay, 1 in 50 papers had features suggestive of deliberate manipulation, meaning those should all be retracted. Now maybe Elizabeth, maybe Dr. Bick is not correct 100% of the time, but she's got a really high, really good track record. And so, if we're talking about 4 in 10,000 papers now being retracted, which is 0.04% versus 2%, which is what she found were retraction worthy, that's a big delta. And I'm not even sure 2% is the right number. It might even be higher than that. What is happening? Journals just really, and she wrote to all the journals about, she wrote to the journals about all these papers, and yet nothing's happening. Some of it has started to happen. That 6 years example was actually one of hers, as I mentioned. So, but again, are we catching them all? And is anyone doing anything about them? And the answer, unfortunately, is no. And the answers are no and no. I want to share with you, this is a little bit more, I don't know how, if I'd consider these data or not, but just to sort of give you a sense of some of the numbers, who is retracting. So we have a leaderboard on Retraction Watch, goes down to 30. And you can go and check it out on the site. This is another slide that when I use it, I have to update it almost every time. Number 2 person on the leaderboard actually just had a whole mess of retractions, and he's creeping up on number 1. We'll see. And these are both fairly old cases now, and the retractions are still happening. To give you a sense of how long they take, the Bolt case is, more than a decade old, and he still has retractions coming out. But if you look at this list, okay, and there's only the top 10 out of the top 30, quite an august list. I'm sure people are dying to be on it. There's 2 things people typically notice. I mean, if we were all in a room and I would sort of ask for a show of hands or what have you, but one thing is that, they're probably a slightly higher than what you would expect rate of Japanese surnames. There are a couple of reasons for that. One is that a couple of these people are co-authors, so they're going to end up on the list together, which just happens. The other is that Japan has quite a high level of transparency about misconduct cases. The law says that universities have to publish their findings, which is not true in any other country really. And so, again, and a couple of these are anesthesiologists, or one is anesthesiologist number 1 on the list. They went through they had a real self-awakening after the Scott Rubin case. And so there's just a lot of reasons why. So I wouldn't read too much into that. One other thing some people sometimes notice is that there are no women on this list. And in fact, if you go all the way down to 30 on the list, so our whole list, there are now no women on the entire list. Now, there was a woman toward the bottom of the list until I think it's about 2 weeks ago. Now there are none. Now 30 is arbitrary. I mean, if we went to 50, there would be excuse me, women on the list, but they're certainly not prominent. And so, you know, in the spirit of equality, egalitarianism, I would urge, you know, anyone who, you know, has a way to, no, I mean, obviously it's just, I don't even know what to make of this number or this lack of number. I will say though, that, you know, somebody actually studied in a smaller data set, you know, okay, well, what does this mean? If you control for the if you will, the overrepresentation of men in authorship positions and in science in general, right? You still have a 9-to-1 men to women retracting for fraud. So I don't know what's happening. People smarter than me probably have some very good ideas about it, and they should study it. But it is what it is, as we unfortunately say. So what? But on a much more serious note, okay, what's important here is that these papers that get retracted, even when they do get retracted, which is again only a small fraction of them, they persist, and they're sort of like, you know, rotten fruit that just keeps the entire trees, you know, they're rotting the entire bushel, you know, of apples, whatever the tree, whatever the metaphor is. And so this is a paper, and Allison Howard, as I mentioned, is the third author. She's our researcher, and this is just one of several papers that have found almost exactly the same thing, which is that when retracted papers are cited, more than 95% of the time, they're cited as if they had never been retracted. And it's wasteful. It suggests that people either aren't paying attention or are actually going down paths that have already been, you know, they're known to be dead ends, and people are spending time, resources, energy on them anyway. That's not good. Now, why is that happening? One of the reasons it's happening is people copy and paste reference lists. That's, I mean, it's really not good. I mean, really bad, in fact, but that's true of retracted and unretracted papers. But one of the other reasons it's happening, and this is again just one example of many papers like this. This was done by two librarians at University of Minnesota. They looked at again the mental health literature. 40% of the time, when you went to PubMed or Web of Science or the publisher's website, 40% of the time retracted papers weren't marked that way. So you can see how, if anything, it's you know, wonderful that anyone is knows that these papers are retracted. Again, this is because publishers just aren't transmitting these metadata. They're not set up to do it. And, you know, that might have been okay 20 years ago, but at this point, people have been thinking about this a while. You would think that there'd be patches. I mean, if I you know, I've got my phone here, and like, I'm sure that in the time I've been speaking to all of you, I've got like you've got to update your, you know, whatever, you know, my Gmail or whatever other app there is on there. You know, you would think that by now they would have, you know, this content management systems would have figured out a way to, you know, get it right. It just hasn't been a priority. That's the problem. But we have a solution. Okay, you know, here I am. I guess I'm selling you something, even though it's free and I don't get paid. So I'm not sure that counts as selling, but certainly we do want, in all seriousness, people to use this. Some of you may use Zotero. It's an open source, free bibliographic management software program, and they do other things too. But we partner with them, so they get a download of our database every night. And if you've got a paper that's in your personal library that gets retracted, you don't even have to think about it. You don't have to do anything. You get a ping, you know, kind of the following morning, or I don't know, some period, 24 hours or something. And it says, hey, by the way, it's been retracted. Now, you might not care, or you might know that or whatever, but a lot of people don't seem to, because we get these tweets that say, wow, this is really cool. I've never seen this thing before. And now I'm getting an alert. Thank you, Retraction Watch and Zotero. So again, free, sign up for it. Use Zotero. We love it. We love having the data be useful. We hope, our hope is that, you know, this will cut down on that sort of problem of continued citations as if papers have never been retracted. And so let me sort of, in the last few minutes here, just sort of maybe bring this all together a little bit. And so again, thinking about the frame of does science self-correct, I would argue that it does, but on a sort of geological scale, but that maybe things are speeding up in some areas thanks to a much more public and robust system of post-publication peer review than we've ever had, okay? And so some of you may know pubpeer.com. I'm just full disclosure, I'm a volunteer on their board of directors. So obviously I think very highly of it and support their mission. You can leave comments on any paper that has a DOI or a PubMed ID. You can leave them anonymously, which I know some people don't like, but as we all know, in science and in academia, it can be very risky to call into question results or findings or what have you from a senior person or from anyone really. And so anonymity, we think, is unfortunately necessary. But this is just one example from a while ago now of a paper that was retracted because people pointed out on PubPeer that there were issues. And Elizabeth Bick actually posts all of her comments and things, her critiques, to PubPeer now. So again, one mechanism, but it's kind of like having a public journal club, an online public journal club. And so, people, this is definitely having an effect. And I mentioned Elizabeth Bick, and also that she is one of a number of sleuths who, and you can't read this slide probably, but you'll have to trust me, but there are more than 24 people on here now who have, again, in some way done something like Dr. Bick has done. There's Michael Doherty, you see there, David Allison, who I mentioned, others, the Boland and Avenel sort of group, I mentioned the paper by them. There are many others. And so it's nice that in this sense that there's sort of, it's like Darwin's finches, there's like a speciation. So Dr. Bick does, sort of image manipulation, image issues. Dr. Doherty does plagiarism. Jennifer Byrne, Dr. Byrne in Australia looks for some, evidence of sort of genetic, these DNA constructs that it sticks out because there are errors in them. And so she's looking at something very specific, and all other people look at statistics. James Heathers and Nick Brown look at statistics, for example, and see issues that you may have heard of the Bryan Murray case. He was a nutrition, sort of a food marketing researcher at Cornell, who now is no longer a food marketing researcher at Cornell, and just really weird statistics and stuff that didn't hold up. And they did a lot of the work on that after a couple other sleuths kind of pulled them into it. So really cool. And like these are the folks doing the work. We're reporting on the work, and yeah, the database is a lot of work, but these are the folks who are actually finding the issues. The question is, what is science doing with them? And frankly, is this scalable? Because right now, most of what these people do is not machinable at all, which is an opportunity, frankly. And a lot of people, I spoke at a meeting about a month ago where people are trying to work on that. DARPA is actually interested in that. So that's kind of cool. And people are making progress. But, then sometimes the sleuths are right in the lab. This is a grad student who very courageously, said to her supervisor, I think I found a big mistake here. And turns out she was right. They had to retract a paper. It may have affected hundreds of papers. Again, unfortunately, in most of these cases, when this happens, people are, for good reason, too scared to say anything, or they do say something and nothing good happens to them. Maybe they're sort of branded as like a troublemaker, no room for you here in the lab or in science. This was a good story in that she was able to come forward, and now everyone frankly knows how smart she is, and how diligent and careful she is, and frankly, I trust her work maybe more than I trust a lot of other people's work at this point. But so it's something where we need to promote this behavior. We actually have a category on the site and an award called the DIRT Award, the Doing the Right Thing Award, which we in which we try and promote behavior like this. Journals are doing something. Some of them, a small number. They're hiring people sort of who actually look at all the allegations people send, and also start to look at the manuscripts as they're submitted. So you're doing more quality assurance, and yeah, those journals like PLOS One in particular and Journal of Biological Chemistry, they end up in the short term having far more retractions than a lot of other journals. But you know what? That should be seen as a mark of, pride, sort of a badge of honor, because again, they're clearing out the stable, they're cleaning out the stables, right? And then in the longer term or even the midterm, you're going to be able to trust what they're publishing, because that more people have looked at it, and their peer review systems, which do include now some staff that are looking at things, that's, they're more robust than others. So that's really cool too. And then again, so this is another example of someone who found, and who was in a pretty vulnerable position, not a grad student, but Kate Laskowski is a junior faculty member, or she was, I think she still is. She was at the time that this was published. This is on Retraction Watch, but that's a quote from her blog. So she actually wrote a blog before we even heard about it and tweeted it. And that's how we found out about it. So, and she's been involved in this rather unfortunate case, much larger case, involving someone named Jonathan Pruitt, who's a spider researcher and a pretty prominent researcher in Canada up at McMaster. And he, the data that he's been providing to people over the years from the field has come into serious question, including by Professor Laskowski. And so she, realized it was an issue, was one of the first to retract the paper. I think he's had 8 or 9 retractions now. And because of what he does, because of the way he works, the data are shared with lots of collaborators, and she's, of course, one of them. People are coming forward about this. The very same month, this is January of 2020, excuse me, the very same month, a Nobel Prize winner named Frances Arnold, who's out at Caltech, she announced on Twitter she was retracting a paper even before the journal had retracted. It was Science. It was a major journal. Made them scramble a little bit because they hadn't actually published it yet, and like, oh, well, now everybody knows, but this paper is still there. So, but again, and now she's a Nobel Prize winner, right? So it's not going to really, in fact, it helps her. I think it helps her reputation to have come forward, and it was work that she had done after, and it was probably someone else in the lab who had actually committed misconduct, and she recognized it. So in any case, lots of good things are happening. I would argue science is still slow, particularly scientific publishing is still too slow to, they can, science can be as fast or slow as it wants, but I think scientists and certainly publishers need to understand the slower it is, the less, trust there is. And so again, you have to calibrate that and and I would argue be more transparent, but people like this are doing that. The sleuths are doing that. Some of the journals are doing that. That's my last slide, just in terms of how to reach me. And some of the first 3 are sort of previous funding, but the other 2 are current. We're a subcontract on an HHMI grant. And of course, we always welcome individual donations and what have you. And I think that Kay put the sign up for our daily newsletter, which is free, in the chat. So please check that out. It's a good way to keep up with what we're up to. And also we include lots of things that other people are publishing, including our competitors. We're happy to do that. So that's a good way to keep up with us. And I thank you all for your attention. And I guess, Kay, I'll stop sharing now and then look at Q&A, or I don't know if you're handling that or.
Yes, by all means, go ahead and look at Q&A. And folks, please, there has to be a few folks that have some questions. Please drop them in Q&A or share them however you choose.
And yes, the role of this list page is on the blog. I'll, while I'm waiting for some questions, I'll just find that URL and put it in there. Yeah, go ahead. Other questions in there? Yeah.
There is one. It says, do you think requirement from funders for study data to be deposited in public repositories has contributed to the number of retractions?
Yeah, here's the link. So it's hard to say. I think that, there certainly have been some cases where people are able to find issues because the data are publicly available. On the other hand, my sort of bigger picture sense is that knowing you're going to have to submit the data, make them public, has maybe made people less likely to publish in journals where they know that's the case if they're going to, commit misconduct or just fudge things a little bit. So it's a little bit of I don't know if it's an iceberg problem or, it's just, there's always somewhere else to go. It's kind of like if you, you move into a new house and you notice that everyone else on the street has an alarm system. So you somehow go on eBay and buy, you don't actually install an alarm system, but you go on eBay and you buy, guarded by whomever or whatever, or you say, we have a tough dog here or something. The thought is that the burglar will just go to the next house that doesn't have one of those. And we have to be honest about that, because it means that the journals that are doing all the right things, that's great. But then there's always some other journal and maybe even some journal that's considered legitimate that doesn't have those in place. So it's a complex question. And until there's some standardization, how do you deal with that? Right? Or do you end up really just punishing the people who are doing it well by creating more work for them?
Yeah. I'd like to go back to that if there's time, but Clark has a question. It says, I'm interested in your thoughts on data dredging and p-hacking. Are you seeing any trends in this type of misconduct? And to what extent do you think pre-registration can help reduce it?
Yeah, it's a great question. I mean, I think what's really interesting for us is that different fields end up, kind of having their awakenings at different times, right? So a couple of the earliest, and they didn't know because they were off in their own silos, but they were happening about the same time, were psychology, particularly social psychology, and anesthesiology. So I've talked a little bit about anesthesiology and how, Scott Rubin, and that led to some other, scrutiny and all the rest of it. But then social psychology was having the same issue around the same time. And of course, you may remember the story of Diederik Stapel, who is pretty high on our leaderboard, but nowhere near as high as it used to be. He was actually making it all up. But then a lot of social psychologists realized that the bigger problem wasn't so much making it up, because again, it's bad, but it's sort of the big, it's sort of what you can see. The real problem was sort of the statistical sleight of hand. And so you'd have, again, p hacking. So you'd see it in that field, and it's still happening in that field. Brian Wansink, it was clearly p hacking. This is the food researcher I noticed. And so I mentioned, earlier. So, I mean, it's sort of, I don't know that we're seeing trends per se, because again, a lot of it's the iceberg problem. Who even knows how common it is? I think pre-registration is a great way to do that. And again, if you look at, I come from a clinical medicine background. And so, and in fact, a lot of people think that because Adam and I are medical journalists, that's why so many of the retractions we cover are sort of medical or related. It's actually just because that's where a lot of them are. And that's where a lot of papers are published. But remember that pre-registration has been a thing in clinical medicine since like around 2005. I mean, it's been the law since 2007, at least here in the States and in many other countries. So, have we learned anything from that would be one way to think about it. And what can other fields learn from the experience of, again, there it was the journals first, and then Congress actually said, no, this is going to be it. Now, are you going to see the same thing in research that doesn't, it's not that it isn't all important, but that a member of Congress can't just look at and understand why it's important to him or her? Probably not. So I don't think you're going to have a federal regulation on pre-registration for, I'm trying to think of something, botany. On the other hand, you might for federally funded research. And I just don't think we know yet whether or not that's helpful. I think it's certainly a positive, but you want to, but there's, even within clinical medicine, there's been some sort of fits and starts and some maybe over-interpretation of what moving the goalposts, in other words, like secondary endpoints and things like that, which is a bit different from p-hacking, but not really. It's the same kind of pre-registration. Pre-registration should limit that, but hasn't necessarily, and what have you. So jury's still out, but I think it's definitely worth trying.
So just on the chance that there's a few in the group that don't know what p-hacking is, would you mind doing a quick explanation?
Sure. So p-hacking is basically, and so p is, refers to p-values, of course. And so the notion that if you, and I think the term was used, I forgot the name of the person who asked the question, but, data dredging is maybe a more descriptive way to think about it. So you're studying something, and if you have enough variables, and you're asking, maybe you're doing 20 different experiments or changing 20 different variables, statistically speaking, and this is a vast oversimplification, but maybe one of them might actually show something. But if you don't say, by the way, I did the other 19, and one of those, by the way, was the one I cared about at the beginning, and it didn't work, you're really misleading, on what the research found. And it's, what is, and again, this is all like sort of the colloquial language we use, which isn't exactly correct, but at least gives people a sense. It's cherry picking, right? It's sort of, okay, those findings mean I found something, that there's something interesting here, but all the other ones that actually I did, I'm not going to report those. And when you pre-register, you're actually saying, this is exactly what I'm doing. And so that someone would then know, they have kind of an audit trail of, well, wait, you didn't set out to study that. How did that happen? Are you sort of only being selective in your data in your presentation, which may it doesn't give the whole picture. It's like if I, as a journalist, sort of do a whole interview and people say all sorts of things, and I only pick the ones that, prove my point, if you will, like sort of, tell a certain kind of narrative. That would be the journalistic equivalent of p-hacking.
Thank you. Okay, a couple more questions. I'm going to start with Casey Lowry's, because I think you can give a pretty good summary here. If a journal has a lot of retractions, would you say that means they're less trustworthy, or more because they're making an effort to be transparent?
I mean, I would say that almost certainly more, because I think that no journal is publishing sort of the right number of retractions yet. So maybe a couple are getting there. So I would say more. And this is why, by the way, people come to us sometimes say, oh, we want to use the data to create a metric, the retraction metric or something. And I say, well, what are you going to do with that? If you have more retractions, you're going to say that's bad? Because no. Now, I would say if you're publishing more retractions and you're not explaining why you're doing it, why each of the papers is being retracted, that's a transparency problem. But I say 3 cheers to journals that publish more retractions, because any journal that says, well, we don't publish retraction because we don't have any papers that are problematic, that's great for them. That's really great for them. And you know what? I'm not going to read you anymore, because, again, do you want to read a newspaper that never publishes a correction? Or do you want to read a newspaper that every morning sends you, I mean, now I'm being sort of a certain generation to even talk about morning newspapers, but, you want to read a website that never publishes a correction? And there's actually in journalism, there's a whole sort of set of systems around that. No, now, do you want to read a newspaper that has a correction on every single story or several? Well, then you want to say, well, are you doing any checking beforehand? But, whatever that right number is, I don't think any journals are at it yet. So I really don't think any journals are above it. So I say more trustworthy if you're publishing more retractions.
Okay, so yeah, as time goes on, we're getting more questions. This one's from Joe Price. As a reviewer, I and others have tended to rely on PubMed to see if work has been previously published. I worry about missing things in journals not covered by PubMed, especially some very niche pubs. Any suggestions other than brute force online searching, or on the problem of stat methods embedded in papers in other fields?
Yeah, so there's a lot going on there. All good questions. I would say, now Google Scholar is really permissive. In other words, like you don't know what you're looking at often, and that's its own problem. But it is certainly more universal, more global. I would argue, and I love that as a peer reviewer, Joe, you're actually asking that question, because I think a lot of peer reviewers either don't have the time, and they're sort of journals aren't really helping them by doing that. And there are now systems where you can look, what's being cited. You can actually, and again, we're hoping that some of those systems actually pull in retraction, our database too. We're happy to work with them. So there's a lot of places to look. I mean, the stats thing is a whole other, I could go on on that, but I feel like, honestly, and this is not a helpful answer, I'm sure, but journals need to pick up some of that slack. Like they need to, especially some of the big publishers, like be using systems. The publishers can hire people, biostatisticians or whatever kind of statisticians. Again, there are some journals that do that, but that needs to be much more widespread, because to expect a peer reviewer who's doing this work for free, who is already spending probably a half day, from what we understand, I do some of them, but half day to a day, to then have to do all these other things, like, you should get a report on Authenticator, on plagiarism detection software, to understand. I mean, actually, some journals do that. Like, those are all things that journals should be doing, again, if they want to encourage trust.
All right, well, we are almost out of time. I'm going to give you this last one, and I will encourage anybody who has additional questions to make sure and put them in Slack, and I will share them with Ivan, although I think he joined our Slack channel, so he may be able to answer directly.
I got an alert for it. I didn't, because I have like 8 Slacks at any given time with all my jobs, so I didn't, but I'm happy to hear from anyone. Yeah.
Okay, so this question is for, and apologize for the inevitable mispronunciation. Morenike Falayan from Nigeria says, how do we handle predator journals here? what's your thoughts about predator journal and what it means for publishing manuscripts written based on misconduct?
Well, let me try. I think I understand the first half of that a bit. You know, I sort of got that a little more clearly. So, you know, predatory journals, I don't love the term. I think it's a very loaded term, and I understand where it came from, and I'm not judging Jeffrey Beal, who came up with it, but it assumes certain things, and frankly, it also assumes that there's a sort of binary in the world of this is predatory, this isn't predatory. At the end of the day, I think you need to check whether or not, can you tell whether or not, you know, a journal typically does peer review, because there are some journals that honestly would never be considered predatory by many definitions because they're at major publishers, but they, from best I can tell, they don't really do peer review. Now, Cabell's is a list. It's a, you know, it's a company, a for-profit company, so they charge, but libraries often have access to Cabell's list. And so I would work with a librarian. There's Think, Check, Submit, which is a resource that people can use. But, you know, librarians are your best friend when it comes to this. And if at your local institution, there isn't a good resource like that, find someone maybe somewhere else who is a good resource. Librarians love to help. I'm on listservs with librarians, and they're terrific. And you know, we work with them actually on the database. It's so wonderful. But you know, they can suss through that because it is confusing. Now, in terms of misconduct, I guess I didn't quite follow that question. Happy to follow up. But you know, someone actually published something the other day saying, "Oh, publishing in predatory journals is misconduct." That's an interesting sort of approach, but it's not really, you know, misconduct requires intent to demonstrate. And so if you didn't know, and you really didn't know, as opposed to sort of claiming after the fact you didn't know, I'm not sure we can go there, but you know, it's interesting, to certainly worthwhile thinking about.
So maybe I'll toss this in there and just offer the suggestion that possibly what that meant was that with a predatory journal with essentially no peer review, you know, causes facilitation of publications that are,
Yeah, no, that's certainly possible. It's certainly possible, but the incentive to publish in those journals, because they're not typically indexed, is lower. So in fact, when you look at the incentives, I would argue that they're higher in the sort of, again, impact factors got its own issues, but in the journals that, you know, funding agencies and governments and universities look at when they look at grants and tenure decisions and things like that.
Yeah, good afternoon, everybody. So it's an absolute pleasure to be here. And this conference, the way I've been looking at things and just listening, it leads me to believe, I think this is what a lot of us are thinking about. How do we do research? How do we teach students? So this is just a very, very timely discussion. So if I can, let me share my screen, or at least the slides. So this is just to give you a little bit information about my background. So I'm the Assistant Vice President for Research for Cyber Infrastructure. I'm the Director of High Performance Computing Center here at Oklahoma State. The other thing I also do is I'm a professor in Department of Physiological Sciences. I have a NIH-funded research program here. So in terms of the challenges for data research and educating the students, and this is something which a lot of us have been thinking about. So the way I would like to say this is several years ago, several decades ago, the way research was done was typically, if you were an experimentalist, let's say a chemist or a biochemist, teaching students would basically mean teaching them how to do wet lab experiments. Everything was posed into a question, then you would go into the lab, and then you would actually do experiments. But in a matter of 20, 25 years, everything has changed how we are doing research. It's now driven by modeling in many, many domains, especially related to environmental research and climate. It is about modeling and collection of data. So every question you ask is driven by what data can you collect, how do you collect it, and what's the information or knowledge you're extracting from the large data sets. Now, introducing students or even educating them in these domains basically means is to teach them how to walk first, which is teaching them how to use the computational tools or programming as the first step. If you want to teach a student how to look at a large data set, it doesn't make any sense for them to start looking at a data set if they don't have any context of what those data sets are. Can they open these data sets and they can even process any of this? And this is challenging. So one example I would like to mention is that when students come into my lab, and not just students, we're talking about postdocs, it's a real challenge because as individuals, we don't understand the value of data. If this is data which is collected by the labs, and could be hundreds of thousands of dollars or millions of dollars, and students don't have the context, they can actually delete either by mistake or say, oh, you know what, let me just empty space, my disk drive is full, let me just delete it. They don't realize that they can actually make changes to the data set. And this is challenging. So I mentioned to my students that think of data as very expensive glassware. Be delicate with it. Don't play with it just because you can, but think of it. The first thing you should be doing is copying. Don't work on the concrete copy, authoritative copy, make a copy. And if you cannot make the entire copy of the data, make a copy of the portion of the data that you will be working on. And teaching good discipline and good practices. The other thing I would like to mention is when students come in, one of the challenges I feel is they really want to just go to the last bit. They want to do the research. And sometimes I actually hold them back for a reason. I say, you have to do the first thing first. You need to learn how to compile code. You need to be able to program before you can use the programs. And the discussion quickly goes to, well, this doesn't make sense. I should be able to download the program and be able to use it. But what I gently remind them is that garbage in, garbage out. If you don't understand what you are actually doing, then it doesn't make sense what you're going to get at the end of the day in terms of results. So for them to understand that so one example is if a person just downloads a code which was compiled or developed in Python, let's say 2.7, and when the operating system is upgraded, the computer has changed, now the Python flavor is 3 point whatever, it doesn't work. And the student is completely clueless. So for me, it's very important for the student to learn that, look, this is how you compile code. This is how you actually run these things. And then everything will fall into the place. And this is an ongoing discussion. So these are the challenges of handling data. Now, the other bit which I would like to discuss real quickly is about courses. So everybody, including the students, understand that they need to have the right background and understanding of how to be able to program and look at computational modeling. But who should be teaching these courses? And this is a real challenge. Different domains require different tools and techniques. So it's not a one size fits all, that we can just teach a computational set of courses and say, okay, you know what? You'll be working in microbiology, doing bioinformatics. This is the same thing as being able to use the information in climate research. So who should be teaching these courses? The domain faculty, environmental research and climate change. The faculty does not necessarily have the time to do this and may not always have the up-to-date expertise to be able to teach these courses. So the proposed solution, which has been successful in many places, is to actually have shared courses. So the faculty from different domains sits down and says, okay, these are the core things. And you can always divide some of the courses into the basic requirements. You can actually have programming, parallel programming, scripting, high performance computing, and you can actually include this as a core set. And then if you want to branch out, if let's say the climate research is going to use a large data sets, you can actually look at handling things differently, NetCDF, HDF5. So you can actually branch out that may not be required in other places. One of the challenges that all of us has faced as educators and researchers is that the computing and computational modeling and programming, the material is so new. Every time I look on the web with a new software tool, there's a new programming language. And I've just stopped tracking them because there's so many, almost, I would say, one per month that I learned about. And when that is happening, the teaching material does not necessarily exist. So how do you address this issue? Because the material is in flux, the programming models are in flux, the programming languages are in flux. Python is so different. When I started programming, it was Fortran 77, then C, then C++, and now it's Python. And I'm hearing now there are another dozen which are going to be the latest and the greatest. So the opportunity I have, and this has been done successfully in many, many different places, the way to think about this is to have a center for data-driven discovery at OSU and other places where you have different people coming together, bringing different expertise, because we may not have the time and expertise to do this individually, but bringing together and developing a core set of classes and also research experience programs would be beneficial for the students. And the last bit is for the students to be successful in these in this domain and also related domains, they have to get hands-on experience. So we can talk all day, all month about this, but what we need to do is we need to also give them hands-on experience. And where are these resources to be able to give the students the hands-on experience, whether it's the cloud or high-performance computing center or whatever the group resources are. Not all groups have access to these resources. So we need to have a dialogue about being able to share these resources. The other bit very quickly I'd like to touch upon is that the technology, underlying technology is also changing, not just the programming aspect. The GPUs 10 years ago, they were new, but now they're so common. Now the CPUs are changing. So with the low power processor, the ARM processor, how the programming models will be developed is going to be drastically different than Intel or AMD processors. And this is something which will impact research in many, many domains. With that said, I think this is an opportunity, especially HPCC, my center will play a big role. What we are planning to do is organize a set of workshops in partnership with domain faculty. So this would cover multiple aspects here. We can cover the basics of high performance computing and also educate students about the technology as it stands today and where it could go next. So they can actually start productive research experiences when they are ready to take the research hands-on. With that, I think I'm out of my own time, so I'll stop here.
Very good. Thank you so much, Pratul. Just a reminder to everyone, please definitely use that Q&A function to ask questions of the panelists. And at the end, we should have plenty of time for additional discussion and questions then as well. But with that, I'm going to turn it over to Bryan Murray. Bryan is an assistant professor in natural resources ecology and management here at OSU, and specializing in forest ecology and geospatial technology. So Bryan, we'll turn it over to you.
Thank you, Kevin, and thanks everyone. I'm happy to be here and presenting, and so I guess I'll see. Go ahead and share my screen real quick. I just had a couple of slides to share. So just a quick introduction. I'm an assistant professor in the NRM department at OSU, and Kevin said, can you guys still see the screen? Sorry.
Yes.
Okay. Yep, assistant professor in the interim department. And I teach a couple of geospatial and GIS related courses, like our geospatial technologies for natural resources, which is sort of an introduction to geospatial, to GIS and a little bit of remote sensing. Our applications of geospatial technologies, which is a more of a hands-on learning course, and then a spatial and non-spatial database management course for natural resources that is for graduate students. And my research generally focuses on issues related to ecological resilience and other things related to spatial ecology. So in the classes that I teach, one thing, both here and when I taught in an environmental science program, many of the students who take the classes that I teach are generally more interested in working outside, or they didn't really major in natural resources or environmental science to use computational technologies. And so some of the challenges that I've had are just things like building the motivation, kind of motivating students to understand why this is important and why it's a really important job skill for them to master, and also just building confidence. I've had some students tell me that they're just not good at technology, and so trying to take that and build new confidence in being able to use the technology. And so I generally focus on, like I said, building confidence and providing a framework for learning new skills. We can't expect to teach really advanced, we can't teach everything in a single semester. So if this is the only course in geospatial technologies a student will take, like, how do I focus on helping them build a frameworks to make them into lifelong learners? And also, how do GIS specialists frame and approach problems? Like, how can they think about problems in a spatial context, even if maybe they don't come back to use the technology in the future? I think that can be an important skill. And so these are kind of difficult goals to have sometimes. And in my classes, I typically kind of start with some hands-on exercises where students can get start to learn the basics for the software first, but mix in some lab activities that are based on some things that I think that they're interested in. Maybe a lab involving data from forestry or a wildlife example, rather than just generic data, and kind of move that into problem-based learning. So once they've learned the basic tools, I introduce, like, okay, well, you have this question that we need to solve. Like, how can you put those tools together to answer that question? And that is more towards the end of my intro course or in my applications course. And the applications course is basically developed as a service learning course where we work with partner with someone outside of the university to conduct a geospatial project in conjunction with them. And the scenario we create is that the students are basically a consulting firm. And so they have a lot of freedom in developing the project. So that helps with working through problem solving. But through all of this, it's really important to provide the right amount of scaffolding. So knowing, having the right, introducing the right concept at the right time, and not overwhelming students with information they're not ready for. And this is kind of with undergraduate students in mind. I also teach a graduate course in spatial and non-spatial database management. And I would say, in addition to the normal skills you would teach in that class, I have my grad students develop a data management plan. And I think it's helpful to know, to have that experience of developing a data management plan, potentially for a grant proposal that they may be writing someday. And so just being aware of that. And I think I've had positive feedback from graduate students that you know, understanding how to organize their data was something that maybe they didn't appreciate initially. I think it's something that a grad student, and many of us are often interested in the question, and we kind of want to rush through that and not do a good job of organizing data. So in summary, these are the, you know, some of the challenges that I've encountered and some of the solutions that I've found, but it's this is a challenging thing to do. So that's my presentation, and so thank you. Oh, and I'll do the, there we go.
Okay, well, we've got a couple of minutes for questions. If there are any questions for Bryan right now.
I have one. I can't use the Q&A because I'm the host, so I apologize for that. My question is, you hit on something that I have discovered in all phases of my life and career, even as a parent, which is, you know, trying to get students past the hurdle of thinking they're not good at it, and frankly, they're afraid of it. And so have you, you know, do you have any insights about ways to do that as early as possible, help them get past that?
I don't have, well, I'm not sure I have like a, you know, a perfect answer, but I think that's where providing the right amount of scaffolding, like basically to not overwhelm a student with too much, asking too much of them or expecting too much early on. And so in some of my earlier activities in class, I try to do some activities that are more, try to build their interest in the topic, but not be too technical. And then it's kind of, I guess the idea is to kind of lead them into using the technology without really realizing what they're doing, and sort of appreciate the power of it. But that's not, I guess, not always an easy thing to do. So it's definitely a challenging topic. So.
Any other panelists want to add on to that? All right, any other questions before we move on? All right, well, thank you, Bryan. We'll look forward to visiting with you more in a few minutes during the Q&A session. Our next speaker is Jamey Jacob. He is a professor in mechanical and aerospace engineering and the director of the Unmanned Systems Research Institute. So they do a lot of work with drones and imagery and dealing with large data. So Jamey, if you want to take over.
Great. Thank you, Kevin. I really appreciate that and the opportunity to speak. You know, I'll obviously be providing a perspective from the drone scenario, which is really looking at big data, not only issues, but also opportunities. And these are, you know, some things for students to think about because they're going to be at the forefront of this transformational exercise that we're going to see over the coming years. You know, really exciting time in the environmental sciences to be able to use all these new tools to be able to get new data and observations. And if we look at it from the climate change standpoint and opportunities that climate scientists and atmospheric scientists are using now, it really goes back to providing an entirely different picture of what's happening in Earth's atmosphere. And traditionally, you know, we've really been capped in terms of what we can measure, our ability to go out and essentially touch something in the atmosphere and get actual data from that, which is particularly important if we want to not only get data for weather, but also for climate. And as an example, if we're looking at weather measurements, Those are typically limited to balloon type of measurements or things that we have on the ground. Now, of course, we've had satellites, and satellites provide a great visual detail of what's happening from the top down, but they're limited in both what they can see, when they can see it, as well as the types of measurements that they're able to get. There are just some things that you have to be able to touch to get accurate measurements of those. And so, what unmanned systems or drones are going to be able to do is provide us a capability to get data directly within the environment that we're operating in. So that way, that becomes a real useful enterprise for us. And we can kind of think about it in terms of a big data problem, because traditionally what we have is relatively sparse sampling, where we have small points that we're able to touch and get measurements from. But with the advent of these new systems coming online, we'll be able to get abundant sampling. And this is really starting to open up new opportunities where students can come in and think about things from a new perspective that haven't been tried before, because basically we tend to get set in our old ways of going out and taking measurements, where students will be able to look at things from a new perspective, and not be used to doing things the way that we always do them, and apply the new technology, really, which they're very used to from an early age, and figure out how to get the new data. And what's exciting about this is it gives us new ways to actually not only measure, but also visualize. So we can start to see, beautiful maps of what's happening, within the different environs of the Earth, not only the atmosphere, but, also the ocean. So that way we can start to build up a picture of, what's happening over time. In this example, just a kind of a standard morning in Oklahoma, where now we can see the growth of the boundary layer that we have in the morning as we start to see the transition from sunrise throughout the day, and see how that impacts the atmosphere. Now, we've also been using high-performance computing resources to start to plan these types of missions. For an example, if you want to map out a large area around a severe storm, how do you go about doing that? Well, it's something very difficult to go out and test, because you don't have the opportunity just to fire up a storm and see what works and what doesn't work. But what we can do are use those high computing resources to be able to generate the environment virtually, and then virtually fly or operate drones within an environment, and see what works and what doesn't work. And again, this provides a great sandbox for students to think about in the future about how they can generate these virtual environments and try new things out. Whoop. Sorry about the sound on that one there. Now, this is not only focused on drones, which we think about in the air, but we're also doing this on the water as well. And that provides us the capability to map out things such as water quality and other environmental parameters that might be related to pollution, or HABs, or other instances that we might see species monitoring. And so we can do this in new ways, and be able to get the data really in a fraction of the amount of time that we've gotten the data in the past using traditional resources. So the students now have to think about this in terms of, well, I can use these tools to get more data much quicker, but like was mentioned before, garbage in, garbage out. You got to make sure the data that you're getting is good, and you actually know what you're going to be doing with it. Just having a lot of data by itself isn't enough. And this always brings me back to what I like to talk about is the hype cycle. This not only applies to drones, but any type of new robotic technology where we have some new flashy tool that comes about, and we get into what we think of as the peak of inflated expectations, where this latest tool, or I like to think maybe the latest code. And I'll give a shout out to those of us that were steeped in Fortran 77 way back on, who still have to go through the process of trying to get caught up and learn the new latest greatest code to be able to keep up. But something else may come along that's better, or that product is not necessarily going to work like we expect it to. As we really start to put these tools out into the field and really test their limits, we fall into what is called this trough of disillusionment, and it takes time for the users to be able to provide feedback to the developers before these tools finally become productive. But what's really exciting about this is most of the students coming along are what we like to call digital natives, where most of us on this panel are really digital immigrants. We started to see digital technology come about in a very gradual fashion, where now we essentially have an iPhone or iPad from the moment that we're born, and we can start to operate those, and that provides a very different mindset for those that have grown up with that capability to start to implement new ideas of how we use these technologies. And furthermore, things are just getting cheaper and cheaper. The ability to have microcomputing resources in the field, gathering thousands of points of data continuously, is only going to become more ubiquitous over time. So that way we'll have sensors everywhere that allow us to measure environmental variables. But like I said before, at the end of the day, we have to figure out what we're actually doing with that data. Just because we have it, doesn't mean that it's necessarily going to be useful, particularly in trying to understand something as complex as the climate, and turning that into usable data that we can then input into climate models. But drones by themselves are going to become great resources in terms of being able to pull data together. Here's one example. This looks like a kind of a blurry photograph of the library, but it's actually stitched together from hundreds of different images, which generates a full virtual capability for us to work and modify this model in a virtual environment, in a full 3D virtual reality that we can pull together. So we'll have lots of capabilities that will provide us really unique resources, and I think it's an exciting time to be a student, to be able to start to pull these two different worlds together of these computing resources and touching data in new ways that we haven't been able to do before.
Well, I think we have a few minutes for questions, and Jamey, I'm amazed at all the work that y'all are doing there always, but how do you transition your students into being able to work with these big data sets and imagery? How do you onboard them, or do most of them come educated and ready to go, or do you have kind of a training program?
No, I think honestly we're probably not doing nearly as good of a job as we could be doing, because it's still kind of an ad hoc process. I think most of this technology is so new, and the capability to gather so much data that we're still in the process of learning as we go. And one of the issues is we have different fields that have different perspectives that are all coming together. I mean, as engineers, we tend to develop the tools, but we're also very interested in figuring out how these tools can be used to monitor the world around us. And so kind of being at that intersection provides some unique challenges that require students to be very creative and essentially lifelong learners, which I think is true for all of us here.
Mm-hmm. Well, sorry.
You see the questions in the Q&A, Kevin, or do I need to read those?
Do we want to take those now, Kay, or wait till the end?
That's entirely up to you. Perfectly fine.
So I think we can take a few of these questions.
Okay. All right. Well, if you can see them, I'll leave it up to you.
Okay, the first question is, what is your experience with international students and how do they perform with the use of drones and large data sets, especially those who come from countries where the use of computer is still rudimentary?
Yeah, I guess I can take that. I think what we tend to find is most students of a certain age tend to do pretty well, because I think everyone within the collegiate age group right now is still pretty used to using technology, computers, cell phones, smartphones from a relatively early age. So yeah, I don't think we see much difference, between the usability of those systems from international versus U.S. students. I do think that U.S. students still tend to have better hands-on capabilities in terms of working with the systems, to be able to, the U.S. tradition of taking things apart and tinkering with them and putting them back together. But I think also we're starting to see that transition a little bit with the ubiquitousness of these small-scale, very inexpensive microcontrollers, like Arduinos and Raspberry Pis, which you can buy for tens of dollars now across the world.
Excellent. The next question is very interesting. The question is, will big data analytics make scientific method obsolete?
I don't know who wants to take that one, but I think it's just quite the opposite. That I think the scientific method just even becomes more important, because you have to have an understanding of what you're looking for within the data itself. And I know everyone likes to get on the machine learning bandwagon, where you're just throwing everything out there and randomizing stuff until hopefully you find some patterns. But the more data you get, the more difficult that becomes. So you really have to have physics start to drive things in order to understand what's happening, in my opinion. And I think that's an opinion.
Thanks, Jamie. There's one more, and then we'll move on to our next speaker. This one is, how do you strike a balance between subject matter training of students versus quantitative tools they need to do that research?
Yeah, and one of the things that I found really useful are the carpentry tools, that have been provided on campus. Those are really great resources that I can start to point students toward, because there's so much now for the students to learn that traditionally we don't cover in graduate courses, since they tend to be so theory based and not focused on really what I call developing skills that they can use for data analysis. So I think a lot of that varies from student to student based upon the research project that they're working on. I noticed that the follow-up question was the carpentry tools. I don't know if those are covered elsewhere within the CADRE conference, but I assume those have been talked about in some of the sessions. And that may be a question for Kay to answer on the carpentry tool side.
I will drop the answer in Slack.
That's perfect. But I think that's one of the great things about OSU that I found is the development of those opportunities for students to be able to use those carpentry tools in the courses.
Great, thank you, Jamie. Our next speaker is Phil Alderman. He is an assistant professor in Plant and Soil Science Department here at OSU, and he focuses on ag systems modeling. So Phil, I'll turn it over to you.
Sure thing. All right, I will assume that you can see it. If you can't see it, let me know. So thank you for the opportunity to share from my perspective, working in the area of agricultural systems modeling. What I would like to do is just to give you a quick intro to what I mean by that. And then I want to walk through an example of a student's project that I'm working with this student right now. And through that, to give just an example of some of the skills that are needed for that project, just to illustrate some of the challenges of doing this kind of research, and then the vast array of different relatively specialized skills that are needed to even solve something that you would think might be a relatively straightforward problem. So what do I mean by agricultural systems modeling? Well, when I think of a model, I think of it as an approximation to the real world that helps us learn something useful about how the real world works. And so there are a number of different types of models: statistical models, numerical models. When I talk about agricultural systems models, they're systems of differential equations that describe how an agricultural system changes over time. So what we're doing here is not a static model. It is a model that's trying to reproduce, or at least mimic, the behavior of an agricultural system throughout a growing season, for example. And so what that might look like is that you start out with a crop that's growing with very little biomass. It's sort of growing throughout the season. And this is, think of winter wheat. It's growing very slowly during the winter season. And then temperatures warm up and you have biomass accumulated at a much more rapid rate. And then at the very end, you'll see it sort of level off as it approaches maturity and it stops growing. Okay, so what we're doing is building models that essentially mimic this behavior of accumulating biomass over time, producing yield of various sorts, which will be different for different crops. But that evolution of the system over time is what we're targeting with these types of models. And so the example problem that I'd like to illustrate is this idea of, okay, what can we do to adapt an existing crop model for wheat for predicting statewide dual purpose wheat production? So what is dual purpose wheat production? But in Oklahoma, this is a very common practice that producers will plant a field of wheat, and then during the winter months, they put stocker cattle out on that wheat to graze it, gain weight. It's a very high quality forage. And then before a certain developmental stage, they'll pull the cattle off and then allow the wheat to then recover from being grazed and to eventually go through the rest of its life cycle and produce wheat grain for sale. And so you might think, okay, well, you've already got an existing crop model. You just kind of need to run it and maybe tweak a few things on it. Maybe that's a relatively straightforward thing to do. And maybe at a conceptual level, that's true. The legacy crop model that we're working with is coded in Fortran. It's a mixture of Fortran 77, but now most of that's been brought over into more modern versions of Fortran, Fortran 90, and some of the 2000s, some of the later standards make it a little bit easier to work with. So for those that were talking about Fortran 77, it's still used. It's still a part of the code bases in various fields. So in some ways, if you're going to take advantage of that legacy code, you have to get familiar with some of these languages. Even Fortran, it's still needing to be taught, or at least have students learn enough of it to be able to modify code, even if not writing things from scratch. But this Fortran is a compiled language. And so what that means is that you don't just write the code and run it. You have to have a compiler and have a knowledge of how to use compilers to pull that source code together and package it into something that can actually be run on a computer. So in addition to knowing the language of Fortran enough to be able to make whatever modifications that are needed, you have to be able to compile that into something that you can actually run on your computer. Well, beyond that, we have all sorts of, when we're thinking about a cropping system, weather data is very important. We have temperatures that are affecting how the crop grows. We have rainfall that's falling and influencing soil moisture, which is affecting how much growth we have. And where do we get the weather data from? Well, they come from different providers. In this particular study, we're using weather data from Mesonet. And Mesonet has their own specific, unique file structure for storing the weather data. And so we have some R code that was developed to be able to read in that format and compile it and put all those weather data files, which are at a certain time interval, and patch them together to have what we need to be able to run the model. Once we have it imported in, we then need to convert that into text files that work with the crop model, the particular crop model that we're working with. So it's a specific format coming in and a specific format going out. And we have had to develop our code to be able to facilitate that process. We get to soil data. Soils are very important for being able to grow wheat, and understanding how different soils provide different nutrients and different water holding capacities and things like that. Very important for being able to get accurate soil data. The NRCS provides a soil data access server that we can query, but in order to access those data, we need to know SQL, structured query language, to be able to put together queries to pull the data that we're interested in. And then we have our code to be able to pull that in and package it. And again, once we pull the data in, we've then got to reorganize it and generate some output files that are relevant to the crop model that we're trying to work with. If the soil data that we get aren't exactly the right variables that we need to run our model, we often have what are called pedo transfer functions, which are mathematical models for being able to translate things like the clay content, sand content, silt content, bulk density, different properties of the soil that are more commonly measured, and convert that into other parameters which describe how those properties affect the soil water holding capacity of a soil. And so we've had to bring in some Python code that was implemented to do this pedo transfer function capability. And so we've got data coming in from the Surgo database. We shuffle that over to Python for generating some outputs. That comes back over to R, and then we write our soil input files that can be read into the crop model. Now, when we're doing something like trying to generate simulations across the whole state, we're talking about thousands of data points and grid points across the state. And to do that in an efficient way, we want to be able to run each of those simulations in parallel rather than waiting one to follow the other, sequentially. And so we are using the message passing interface called MPI, which is used to spread out and distribute the simulation of all of those different grid points across the whole state. And once we have code that can work that way and can work in parallel, we have to be able to run it on a supercomputer, a computer that actually has all of those different cores that we can distribute all that work to. And so we have to be able to know a little bit of Linux shell scripting, and Slurm is the sort of the job manager that we use at the OSU High Performance Computing Center. So that you have to be able to describe, well, what is needed for being able to run these simulations? How does that work? And so there's an additional set of skills. And then once we get all of that output, now we've got all these grid points, we need to figure out, okay, how do we make sense of this? And how do we manipulate those model outputs in a way that allows us to tell a compelling story, to understand what's going on? And so we've got a mixture of our code and some interfaces to GIS libraries, like the GDAL and several other geospatial analysis libraries that allow us to manipulate those model inputs to generate sort of maps of yield and other variables across the state, and allow us to understand what's going on. So when we think about all of these skills, and this is just one student's project, this doesn't even, there are other students in my group that are working on projects that are similar but have different wrinkles to them, and there's a whole other set of skills that are required. But even in just this one student's project, we've got compiled languages, interpreted languages like R and Python, a knowledge of SQL, which is sort of interacting with formal databases, dealing with parallel programming and all of the challenges there, and then dealing with geospatial analysis. So even something that might on its face seem somewhat straightforward very rapidly turns into a whole set of skills from a lot of different domains that are needed to be brought together to be able to solve this one problem. And so this is just one example. Again, like I said, I've got other students in my working in my group where, you know, maybe 70% of the same set of skills are required, but then there's another 30% that's something entirely different. And so because of the number of different dimensions or sort of sets of skills that are needed, there is a real challenge to being able to, I mean, there's no course on campus I can send them to learn these things. You know, there are bits and pieces where I could send them, but half of their coursework would be going and taking a class in NREM on the geospatial and GIS modeling. And there would be another course possibly offered by the HPCC on Python and parallel programming, and another one related to R coding. And so half their graduate program ends up being taking courses in other departments that are just teaching, you know, skills that aren't even related to their domain. So one of the real challenges, and this was one of the questions raised just a moment ago, is if we do set aside time within the curriculum to address some of these skills, does that push out domain expertise that's also needed? I was having some interactions with some of my students recently, and I realized I've done a poor job of, well, I haven't done as good a job as I should have on emphasizing the connection between crop physiology and the models that we're using. So that domain expertise, that knowledge of crop physiology and how that plays into these research questions, there's a gap. You know, they've been spending so much of their time within their graduate program trying to get a grapple with all of these technical skills that are needed to complete their project, that they have not been able to invest as much time getting back to the actual fundamental research questions from the domain perspective. You know, what does it mean, you know, for wheat to grow under grazing in Oklahoma? Because these, you know, the students been spending all of their time thinking about, well, how do I get this data into this format and this data into that format, and then put them together and then push them through the model and get, you know, all of those technical details end up consuming so much of their time. It's very easy for them to lose track of that bigger picture and the actual original research question that we set out to address. And so anyway, I thought that this is a really good example of some of the challenges, you know, when we have all of these different areas that have to be addressed in a technical sense, and how that can often sort of displace or at least cloud out that domain focus if we're not careful. So anyway, I'll stop there.
Thank you, Phil. I really like that last slide of yours that really listed out some of the skills. Maybe when we're done, I'd like to talk about, you know, is there overlap between the different disciplines on some of those key skills? You know, I expect R and SQL and Python and maybe others would be consistent skill sets that would be needed and required across the different disciplines and groups. And maybe areas that we can focus future educational efforts on, you know, both at the undergrad and graduate levels. But thank you for all that, Phil. We'll move on to our last speaker and then get into our discussion time. But our last speaker this afternoon is Jacqueline Vadjunec, and she is a professor in geography, and I understand that she's just getting back from a stint with NSF. So Jackie, look forward to your presentation.
I'm coming at this from a bit of a different perspective. I'm a muddy boots geographer, and I just came back from NSF. So I'm thinking about this in a more philosophical way and a more meta type of way. Right. So coming from NSF, I'm always, where's the money? Follow the money. Well, one of the big 10 ideas is harnessing the data revolution. And this is really about, creating data-enabled futures and teaching students how to deal with big data. So that's one of the big ideas. And another one that I think is really important for the discussions we're having right now is growing convergent research. And when I talk about convergent research, explain it as transdisciplinary plus people, plus citizens, plus businesses, plus other people at the table, because this is how we solve complex problems. And most of the data that is wrapped up at NSF right now is coming from basically these ideas, and a lot of these other ideas overlap those two ideas. So there's a lot of entry points where I think environmental fields can get involved with research at NSF. And all of the things we've been talking about, these new spatial data sources, drones. One thing that I'm really interested in is geospatial privacy and VGIS type of issues with citizen science and ethics, machine learning or AI. All of these issues about data and thinking about the future of data and doing convergent research and making a student, developing students that can do that type of research, that can work with the social sciences. This is the nexus of environment and humans, and that human piece is really important. So things like data revolution, the future of work, convergence, human environmental geographical sciences, dynamics of integrated socio-ecological systems, sustainable regional systems, navigating the new Arctic, coastlines and people, signals, they are all operating at that nexus. They all include big data, and they all need that human environment piece from a convergent standpoint. So this is how I think we need to be training our students, because this is where the bulk of the money is at NSF at this point. Okay, so going to the challenges, that was the opportunity. So the challenges, and this is my muddy boots perspective. How big is your N? Mae West once said, too much of a good thing can be wonderful. This seems to be the sentiment of the times, especially in geography and related environmental fields. During the first week of class, I presented some data on a payments for environmental service program in a small community in the Amazon. A grad student raised their hand and exclaimed emphatically, but your N is small. It was true, my N was very small. It was 40 households and a single community. However, there were less than 80 families in the community to begin with, and even less were involved in the payments for an environmental service scheme for that matter. Further, the households were randomly selected and the small N stats were statistically significant. So permitting me the ability to generalize here and sound maybe outdated, I am a Gen Xer who doesn't trust anyone. Perhaps I watched too much X-Files growing up, but large N data sets are easily available on the internet, and they've made a lot of my graduate students scoff at the idea of small N ethnographic fieldwork. At the same time, I know how my data was selected and collected and analyzed. My graduate students suspicious of mixed methods approaches are often very happy to get all the data they need off the internet in increasingly massive quantities. But I teach a required field methods course. It's a mixed methods course. So students can get their data off the internet, but I also make them go to the field. They often go kind of being late, but they often realize while they're there how important field work is to verify the results, whether it's remote sensing, GIS, or any type of spatial data. Ethically, I believe when we interpret data that can have implications that are either positive or negative on it, we need to see for ourselves. This is what Kant dared us to do, dare to know for yourself based on your own senses. This was the call of the enlightened, this is the call of science. There's a danger of allowing big data to become the new religion, and I think we need to teach students about some of these ethical issues. So I'll give you an example as a remote sensor. In the case of remote sensing, those of us who do it know that land use, land cover change categories are far from clean, crisp boxes being culturally created, constructed, and understood. Researchers, we have an ethical obligation to understand these differences. So anthropologists and geographers like Joel Wainwright or David Salisbury illustrate the power of remotely sensed deforestation maps to tell the story in terms of the person in charge, right? So the remote sensing analysis can prove what the person holding the power wants to prove. So for instance, this is a small 2-acre plot of subsistence farming. Is this traditional Swidden agricultural system deforestation? Is it part of a larger agroforest that's continually in use and going back to forest? Or is it something else? The answer really depends on who you talk to, what their agenda is, and who has the most power. These are kinds of issues that make an important case for the importance of co-produced knowledge and the importance of sort of being leery of all the data we can access on the internet, including remotely sensed data. It's relatively easy to hide behind the power of a large N. Dennis Wenger, a retired program officer that dealt with risk hazards, infrastructure management, and extreme events, once asked, do we really need more Twitter data? Are 4 million tweets really better than 1 million tweets? And more importantly, who's left out of the sample? I believe we have an ethical obligation to be more transparent about the data we're using, the potential bias, accuracy, and replicability issues, instead of hiding behind the power of the N. And I think we need to have these discussions with our students and train our students in this. I'm not saying we should avoid the use of big data, but I'm a huge fan of the scope and limitations section, which a lot of people are reluctant to acknowledge. So here's an example of, I think as a land system scientist, in the early 90s, we talked about metadata issues. We're still having these issues. All the time I get graduate students who pull data off the internet, there's no metadata attached to it. And when it comes to geospatial data, that could cause a slew of problems. And so I don't think we've dealt with metadata issues, but there's also data issues. This is an example of the EWG working group data. I had a student who scraped it off the internet for us. When we got it, it looked a little cattywampus. Then I had a student who I paid as an RA to actually manually cut and paste this data in. It still looked a little cattywampus, but in a different way. And if it wasn't for us in the field for 10 years in this area, we would not have been able to make sense of this data. So I'm making a case for the importance of field work, regardless of the data you get. So talking about the ethics, geospatial data from VGIS, crowdsourced or citizen science approaches is increasingly popular. It allows us to achieve large data sets for relative costs while democratizing science. These are all good things. However, we really need to consider transaction costs, and we need to train our students to do so as well, because everybody sort of jumped on the geospatial bandwagon. From a science perspective, how do we ensure the quality of the data collected? What are the inherent biases of self-selecting group of participants or data collectors? What are some ways to account for these issues? How do we balance the benefits of the known and the potential challenges? And how do we ensure that the human subjects are protected and not exploited? So this is an example of Forest Watcher. I had a million examples of these, but I deleted them. But anyway, this is an example of Forest Watcher. It's a citizen science app which monitors deforestation in real time, and it encourages curious citizen scientists to go to the location and figure out what is going on. This is great for biodiversity. This is great for people who are interested in deforestation. Yet across the world, forest watchers of various kinds might unknowingly be putting themselves in danger as much deforestation occurs in places of conflict. On the other side, marginalized and traditional people, like that example of the Swidden agriculture, have historically fought for their right to practice small-scale, sustainable Swidden agriculture, which is illegal in lots of places. For the record, this app has been used by sheriff's offices across the Amazon and has led to arrests. So what are the implications of seemingly spying on some of the most marginalized groups to begin with? We may have started out with an ecological study, but there's real human impacts here. Here I'm reminded of Foucault's Panopticon and power relations. Watch the watchers themselves. So why does it matter? This is one of my favorite photos from out in the Panhandle. Politics aside, there are often reasons why researchers aren't trusted in communities. If we are to involve people in our work, we can and must do better. For this reason, we need to train students to do co-produced research, to do community engaged research, to get involved with people on the ground, to make for better results for all of us with, to solve these big, complex human environmental problems. Otherwise, we end up with this kind of tension. And why does it matter? Because for every pixel or geospatial piece of information, there's people attached to it. So these are social and environmental justice issues for me. All right, so my conclusions, I really hope to make a case for mixed methods here. I think we need to train a new kind of student that could work across the social and natural sciences, to do co-produced research, to work with people on the ground, to consider these issues that are also ethical as this data comes out. A lot of times data, even if it is public information, once you put it into that GIS database or make it geospatial, put it all in a nice platform, all of a sudden data that was seemingly innocuous is now very sensitive. So I see sort of important ethical conversations that we need to have with our students. And I think we need to kind of think about what is the future, that kind of student we want, and that is needed for these types of complex problems. How do we train people to do convergent research? Thanks.
Great presentation, Jackie. It was very interesting. Let's open it up for questions from the participants as well as from the panel. Well, I've got some, so if nobody else does. So, you know, as I'm hearing everyone talk, you know, I keep thinking about maybe the need for maybe a certificate program that could cross disciplines and provide some of those key skills. You know, it might not get every student you know, to the point that they need it for every single program and dealing with all the different data sets, but you know, back to Phil's skills list, you know, the need for R and SQL and Python. And then to Jackie's point, data quality and data ethics. You know, it seems like there's some key cross-cutting skills and understanding that needs to be conveyed out there that would then benefit, you know, all the different users, data users across the university. So Pratul, you know, I didn't know, and Kay, I know both of y'all do workshops and things like that, but has there been talk of maybe a certificate program, or has there been an effort to organize these student data education efforts more broadly across campus?
So I'll jump in. There actually is a certificate program. It's administered by the grad school, and it's called their 360-degree program. It is not strictly data skills. It's, in fact, it's all the things that grad students need, everything from, you know, professional skills, writing skills, and so on. The carpentries is one of the things that, along with all the other workshops, the Data Bytes workshops and so on that we offer, are part of that certificate program. But I'm going to be a little bit of a devil's advocate and say that although I certainly think that fills a role, but it tends to be, you know, preaching to the choir. The students that jump in and do that kind of thing are the ones that are not afraid. You know, they don't have those fears of trying new things and being exposed to this kind of thing. And, you know, it's still good, but my own bias is that, you know, the best thing we can do is find a way to introduce students just as early as possible. We don't have a lot of control over elementary school, high school, etc. But, you know, if it's your kids, maybe you do, maybe you can have some input. But we certainly have some input with regard to undergraduates. And so that's something I've been trying to kind of do a little bit of getting off the ground. And I've seen Nicole was on here, but I think she must be, maybe she's stepped away. But anyway, yeah, that's one of the things that I think is critical, is finding a way to, and I think Brian's the one that used the word scaffolding, and just expose them to this stuff as early and as often as possible in bite-sized pieces. And I will stop.
So among other challenges, one of the big challenges is to have such a program which is up to date and also appeals to, let's say, specific research domain, you have to have a program which appeals very broadly. So not just the few graduate students. So if you're going to only tailor the program to, let's say, 3 or 4 students per year in a specific program, it's not going to survive. The good thing about what we have been discussing in the last hour is that data, it cuts across many, many domains. That's great. On top of that, if we start thinking about undergraduates, when they're going to go into workforce, we wish many of them become researchers, but we know that's not the reality, only a small fraction. So the remaining ones, they should also see some incentive to take these courses. And I think we need to tailor make these programs saying, okay, if you're going to go work in oil and gas industry, if you're going to go work in, let's say, e-commerce, all these tools that you will be actually exposed to these programs are still relevant for getting jobs in different industry. So I think that's the way to think about this, having, I would say, multi-pronged approach. So clearly the main arm is going to be a set of courses, which is broadly applicable. But then if students are interested in saying, okay, what kind of job can I actually get when I graduate? We should also cater to that interest. And on other side, we can actually make specific courses for advanced research. And I think that's when we can actually get more traction at the graduate level or even at, let's say, senior level undergraduates.
If I could chime in. I do see an opportunity for having possibly some core coursework which has, has some of those key skills being addressed in it. On the other hand, what I find, so I teach a class on, it's called Data Science for Agricultural and Natural Resources. So it's, the idea is trying to make available some of the tools needed for understanding data management, quality analysis and quality control, being able to do, manipulating different data formats and bringing data together from different sources to be able to not just have field data, but augment field data with other data sources, things like that. And what I find is that when I teach the skills just as skills with the sort of cookie cutter examples, the first go round, they get it enough to be able to complete the assignment. But where they really learn it is when they're working on their semester projects, where they're applying those skills to their thesis or their research project. And so I think a key aspect of whatever would be some sort of core curriculum would be needing to incorporate an element in which students are not just being taught skills in general, but that they're being taught the skills that are needed to analyze or manipulate data that's of relevance to them. And I frequently interact with students who took the, two semesters of statistics and still don't know how to apply it to their analysis. And so, it's like there's a danger of having core courses that everyone's required to take if we don't also take care to make sure that we're giving them opportunities to, or in some ways forcing them as they're learning those things to apply it to what they need it for. Otherwise, they go through the course, they learn enough to pass the exams, and then a year later or 6 months later, when they actually come to analyzing their data, they go, oh wait, I vaguely remember something. Can you explain that to me again? And then I, as the advisor, am having to, hopefully it's easier, but I end up having to, review, basic statistics. It's like, you took the class, what, anyway, so I guess I just wanted to sort of mention, there is a tension between having something that's sort of generic, but then we also need to make sure that there's something specific. So I'll yield to Jackie. Looks like she has something to say.
Yeah, I guess I'm probably the generic one in that I think the skills are important but real skill, because you could have the skills, but it's that getting people to leave their disciplinary baggage and methodological bag at the door and problem solve. That itself is the biggest skill. And that, I think, the thing that we still need a lot of work on. And that is where all the money is if you're just looking for research funds. But I mean, whether you're continuing on in academia as a student, that training that person who could be open-minded, do open-minded science, that's the place to be. But also, if you're going out into the world and having a job, I mean, what job doesn't create, like, an example where you have multiple people trying to solve different problems and you're interacting with people? That is the skill that I think we need to deal with. And we've got, like, you know, you have an NSF program like the Future of Work. Our work landscape is even changing, and so the way that we're interacting. So these are the kinds of things I think we need to think about, is how do we train the students that can do convergence, both in the classroom and out of the classroom.
Yeah, and I'll just add, I think, you know, one of the things that I found really useful, or most useful, is some of the courses that my students have taken that have benefited their research plan the most have been outside the department, and some of those outside the college. And we tend not to have enough capability at the graduate level for cross-collegiate coursework for the students. Not only do they, you know, not really know about the opportunity, it tends to be outside their comfort zone for them to go, oh, I'm going to go take a course over in arts and sciences or in NREM. You know, engineers, you know, it's almost verboten in that sense. But I think, you know, having courses that they take over in geology, for example, have been some of the most useful, you know, for their particular research projects. And that's where I think, going back to your original question, Kevin, you know, a certificate-like program, or at least having that opportunity for students to take courses and get some credit for that somehow, because they tend to be so regimented, you know, based upon what they're required to take, and just looking at the bare minimum to be able to graduate.
Yep. We are out of time, but this is a fantastic discussion that needs to continue. You know, as we look to the future, this is our future and the future of our students for sure. So we need to best prepare them, and you know, without offering some of these core courses and getting more students involved in data education, you know, we're not going to prepare them for the future. So this is something that I hope we can continue. Kay, you put in the chat that we can add ideas in the Slack, so we can carry on that discussion there, and maybe be able to get together for some future discussions. So thanks, everyone. Thank you, all the panelists. You did a great job, and thanks for the questions.
Welcome to the afternoon session of the CADRE conference. In this session, we're going to talk about interdisciplinary problem solving with data. And we have 7 presenters lined up. Each of them is going to talk to you about their research regarding the theme of the session. I am going to be the moderator for the program. My name is Abu Mansaray. I am with the Water Center. We have some caveats that we've been following. Of course, I will remind the presenters when the time is 1 minute to go. And then if you have questions, you may type them in the Q&A chat box, or you can wait until the presenter is finished and you ask the question if they have time. Or we may also have time for questions after everybody has presented. So with that, we will go right into it and get started.
My name is Wuyang Qian, and I'm from Industrial Engineering and Management Department. So I'm just going to start straight. So today I'd like to present molecular research for optimal cancer intervention strategies among BRCA mutation carriers. First, I'm going to present our motivation and state of the art. The next thing I will share with you is the methodology we developed. Finally, I will share our results. According to data from National Center for Health Statistics, breast and ovarian cancer is the second and sixth leading cause of cancer death in the US. Breast and ovarian cancer are highly related. Some people may carry BRCA1 or 2 mutation genes. They have much higher probability of developing breast or ovarian cancer than those without mutations. To decrease the risk of developing breast cancer and ovarian cancer for BRCA mutation carriers, several medical strategies have been proposed. For example, lifestyle modification, including controlling weight, avoiding cigarettes, exercising, and decreasing alcohol consumption. Another way is taking medication. However, these medicines may cause stroke or even another type of cancer under rare circumstances. Medical screening like X-ray and MRI will detect disease at early stage, which allows for timely medical treatment. However, it is expensive, invasive, time-consuming, and may cause anxiety, and do not reduce the probability of developing breast cancer. Prophylactic surgery is another proposed strategy. Prophylactic mastectomy involves removing both breasts, which reduces the risk of developing breast cancer by 95%. Prophylactic oophorectomy, which involves removing ovary from the body, reduces the risk of developing breast cancer by 60%, ovarian cancer by 80%. Since the surgeries involve removing body parts, it can only be performed one time. Also, the surgery at different ages will affect the progression of the disease trajectory differently. So when and which prophylactic surgery to take is an important question. Several researchers also developed frameworks to distinguish breast cancer subgroups or tumor types and increase the accuracy of the prediction. However, they're less concerned about the development of optimal intervention strategies to reduce the cancer incidence risk. So our objective is to develop a sequential decision-making framework for optimal cancer intervention strategies. Markov decision process is a model for sequential decision-making under uncertainty. It is widely used in many industrial manufacturing and healthcare applications. This flowchart shows the process of the MDP. We have a decision agent. Decision agent chooses an action. The system will evolve according to the action. After observing the evolved system, the state will be updated. Given the updated state, we can calculate the value function and return it to the decision agent. So the decision agent can make the next decision. The process is repeated until the end of the planning horizon. We will develop an MDP to model the process of breast and ovarian cancer and find the optimal policy for BRCA mutation carriers. In MDP model, there are several important elements. In our specific case, a state contains patient's age, mutation type, health status, substage for breast cancer. Also, the surgery will affect the state, so we add the surgery history and surgery age. In our setting, a patient can receive surgery at any time between age 20 to age 80. There's the example. In this state shows that the patient carries BRCA2 mutation gene, and she's at age 39, completely healthy with no surgery history. There are about 500,000 states in the space. With the state defined, we have to choose actions. There are 4 available actions: PM, PO, PMP, and PO together, and do nothing. These actions can be, the patient can receive any of these 4 actions at any age between 20 to 80. Since the surgeries can only be performed one time, it is state dependent, especially depending on the surgery history. For example, if the patient already received a surgery PM, then she can only choose between surgery PO and do nothing. Here's an example of the process in our case. First, we have a patient at age 29, healthy with no surgery history. The clinician chooses to do action nothing. Then at age 30, the patient could be healthy or suffering from breast cancer, ovarian cancer, or even death. If the patient stays healthy, we can choose the next action. The clinician chooses to recommend the patient to take action surgery PM at age 30. Then the patient could still be healthy or suffering from cancer or death. If the patient stays healthy, we can continue the process. This figure shows the transition dynamics of different states under different actions. The different action will affect the progression of the process differently, the transition progress differently. For example, some action may reduce the cancer probability, but also decrease the quality of life for the patient. We want to find the optimal policy to decrease the probability of developing cancer and maintain a high quality of life at the same time. Before finding the optimal policy, we still need to define an immediate reward for different actions. Immediate reward is the patient's quality of life each year. If the patient is completely healthy and do not receive any surgeries before, the immediate reward will be 1. Immediate reward will be 0 for death. Since the prophylactic surgeries involve removing body parts, it will definitely affect the quality of life. So the immediate reward after action is less than 1. We also define discount factor to penalize the future reward. With the immediate reward defined, in order to find the optimal policy, we want to maximize the immediate reward of the current state with chosen action, plus the discounted cumulative future reward. Now the problem is to solve this equation. To solve these equations, we have several challenges. There is a huge state space, about 500,000 states, as I mentioned before. The prophylactic surgeries can only be taken once, and the effect of the surgery is time variant. To address these challenges, different methods have been proposed. For example, using value iteration algorithm or solve bilinear programming. However, these methods, they solve the MDP with all the states at the same time, which is inefficient for such a huge state space. To address these challenges, we form a monocular tree search model to reduce breast cancer and ovarian cancer risk and maintain high quality of life at the same time. MCTS monocular tree search is a sequential optimization algorithm devised to solve a sequential decision-making problem with a large state space. It has gained success in AI for games, for example, the AlphaGo, but it's not used in sequential decision-making for breast and ovarian cancer. With MTCTS, we do not solve the whole MDP as the existing literature. We solve the sub-MDP from the current state, which will help us balance between the exploration and exploitation and save computation time. In our model for MCTS, in each iteration, there are 4 steps. First, selection traverses the current tree from the root node using a specific strategy. The strategy uses an evaluation function, the upper confidence bound UCB, to optimally select nodes with the highest estimated value. For example, here we have a root node, patient age 29, healthy with no surgery history. Then we choose action nothing. Then the patient become, the algorithm chooses nothing according to the upper confidence bound. Then the patient become age 30, healthy with no surgery. And then algorithm chooses PM again. We again chooses PM according to the upper confidence bound. Then patient become age 31, healthy with surgery PM at age 30. Then the algorithm would choose nothing according to the UCB. Patient become 32, healthy PM with surgery PM at age 30. This is the formula of the upper confidence bound UCB. It is the average reward plus the uncertainty. The exploration parameter here will help us balance between the exploration and exploitation. The second step is expansion. A new child node is added to the tree to that node which was optimally reached during the selection process. Here, the algorithm selects action PO and generate a new node age 33 healthy with action PM at age 30, PO at age 32, and add it to this node. The third step is simulation. A simulation is performed by choosing moves or strategies until a result or predefined state is achieved. Here is the reward. Then the last step is the backpropagation. After determining the value of the newly added node, the remaining tree must be updated. We update the reward through this path all the way to the root node. Here is the pseudocode of the algorithm. So now we apply the MCTS to the breast and ovarian cancer model, and we have some results. This figure shows the optimal strategies for BRCA mutation 2 carriers. For example, if the patient is at age 30, completely healthy, with no surgery history, we would recommend she take action, surgery PM at age 33 and surgery PO at age 40. We also compare the cumulative cancer risk under different policy. The optimal policy, this two, has the second smallest breast and ovarian cumulative cancer risk. This is because our goal is not just to minimize the probability of developing cancer, but also try to maintain a high quality of life. Also, the optimal policy has the second largest health cumulative probability. Even though the optimal policy does not have the smallest cancer risk, this figure of comparing the cumulative reward on the different policy shows that the optimal policy has the largest cumulative reward. This is because we also consider the quality of life in the model. So our policy will reduce the cancer probability and maintain a high quality of life for patients at the same time. In conclusion, we developed a sequential decision-making framework for optimal cancer intervention strategies for BRCA mutation carriers through molecular research. It is a novel framework for reducing the probability of developing cancer and maintain a high quality of life. Also, this methodology can be applied for optimal decision-making of other chronic diseases. Thank you. I'm happy to answer questions now.
Thank you so much for that wonderful presentation. We have time for a few questions. So if you have a question, you can ask now, please. All right, seems like we don't have any questions for you.
Okay, all right, thank you.
Thank you so much.
Okay, so good afternoon, everyone. This is Khyati Chandratre. I am a second year PhD student at University of Texas, Dallas. And it's my pleasure and honor to be a part of CADRE conference. And thank you for giving me an opportunity to present my research work today in front of all of you. And so let me begin with the title of my project. So the title of my project is Integrative Analysis of Multi-omics Data to Uncover Multiple Mechanisms of Transcriptional Dysregulation in Prostate Cancer. So a lot of research have been done in past decades where they've shown that genetic mutations usually trigger and encourage the growth of spread of many cancer types. But prostate cancer has been characterized by lower mutation rates, but it has higher mutation rates of recurrent genomic rearrangements. And they are majority of them, they cause upregulation of transcription factor genes like ETS family genes, V1 upregulation, and more than 50% of the prostate cancer samples. Androgen receptor, it's a master transcription factor and it involves in the normal development of prostate gland. Any changes in the signaling of androgen receptor pathway can lead to many facets of prostate cancer etiology, which also includes metastatic castration-resistant prostate cancer, wherein the cells, they divide and grow even where the testosterone levels are very low. So our hypothesis with this particular project is that when if we check the changes in the genome organization on 3D level, it will be very critical in determining the aberrant transcription regulation which happens in prostate cancer, mainly because the 2D genomics data, it cannot give a proper clarity on multiple gene and enhancer coordinated regulations. So to check the 3D genome aberrant changes in the transcription regulation, we did a lot of integration of different kinds of data to get a conclusive idea of what is going on at the transcription level. Androgen signaling in prostate cancer works in a following way, where when it is not bound to a ligand, androgen is in a complex with the heat shock protein in the cytoplasm. When the testosterone enters the cell, it gets reduced to DHT, that's the dihydroxy testosterone, which again binds to this AR and forms a complex where the HSP proteins are dissociated. This complex of DHT and AR, it enters the cell enters the nucleus, where it dimerizes and binds to the androgen responsive elements, forms an assembly of androgen receptor transcription complex along with the RNA pol 2, and this activates the transcription of androgen receptor responsive target genes. On the right-hand side, you can see is a timeline of cardinal genomic lesions in prostate cancer. It begins with from 1980 till 2020, where a lot of different kinds of technologies like whole genome sequencing, whole exome sequencing, expression profiling have led to common consistently found genetic alterations which were found in prostate samples where the patients were hormone naive or they were resistant, etc. So these mutations, these studies gave a list of different kinds of important genes, mutations, and genetic events like chromoplexy, which were found in prostate cancers. Talking about the hierarchical organization of the genome. So when I say that it's a 3D genome, which we are going to look into. So the hierarchical organization of the genome, it involves the genomic DNA in the eukaryotic nucleus. It has multiple level of organization. Primary involves double helix, followed by nucleosomal compaction of chromatin into a secondary. And the 3D architecture is the higher level of organization of the genome into the 3D space of the nucleus, which involves architectural features like chromatin looping, self-interacting associating domains called the TADs. And these domains are confined to transcriptionally active compartments A, transcriptionally inactive compartments B, and then they form a chromosomal territory here, which is and then nucleus has such kind of chromatin territories. These architectural features like looping, TAD organization, clustering, compartmentalization, they have different physiological relevances where they a lot of chromatin and promoter and enhancer communication happens through looping, which helps in coordinating the transcription. And there are different pathological implications as well, where if there is any mutation in the boundaries, it might lead to enhancer leakage, and it can cause silencing of one gene or multiple proximal genes as well. So this is the workflow of the data integration part of the project, where we have used 4 different cell lines. There are 3 cell lines which are prostate cancer cell lines, which are LINCAP, VCAP, which are AR positive. So there is an overexpression of androgen receptor, and the normal prostate cells, that's the RWPE. So DU145 and RWPE are AR negative. So when I talk about the integration of the data, so we have integrated these 5 different kinds of data, which are mainly important in understanding the regulatory concepts which are associated with the transcriptional control of prostate cancer. CHOPET is chromatin interaction analyses of paired and sequencing tag. So basically this maps the genomic interaction landscapes of many chromatin associated protein of interest. In this case, we looked into RNA pol 2 and RAD21 proteins. So this data gives you two kinds of information. One is the binding site of the protein, and second is the chromatin interaction in which the protein is involved. And the interaction can be intrachromosomal, that is between the two chromosomes, or intrachromosomal, that is in the same chromosome. ChIP-seq is the data that's the chromatin immunoprecipitation sequencing, which maps the binding sites of DNA binding proteins. In this analysis, we have generated ChIP-seq data for transcription factors, architectural proteins, and epigenetic markers for active enhancers and active promoters. RNA-seq data was used for mapping the expression of the genes for the regulation part. ACGH is array combined genome hybridization, which locates the genomic imbalances in patient samples. So this was a clinical application, and whole genome sequencing was used to identify structural variations in LINCAP and DU145. So when these 5 different kinds of data set integrate, how well can we deduce the regulatory concepts associated with transcription control in PCA? So this is an IGV image of PCA cell lines. I just wanted to highlight this AR region. So androgen receptor, it's a steroid hormone which activated transcription factor, which is important. And it's clearly seen here in the image that the LINCAP and the VCAP cell lines, they show a lot of chromatin interactions in this region, whereas these two are AR negative and you don't see any kind of chromatin interaction. Here I'm highlighting a FOXA gene. So FOXA gene is a transcription factor, but it also is known as a pioneer factor. So its main important role is opening up compact chromatin regions for other proteins to bind, and through interactions with the nucleosomal core histones. So main important role of FOXA and AR gene in prostate cell lines for LINCAP and VCAP is FOXA, it opens up the chromatin for AR to bind to the response elements, which then activates the AR gene transcription. Here I'm showing KLK3 gene interactions, again in LINCAP and VCAP here. So this particular gene is a biomarker. The protein encoded by this gene is a biomarker. It's a PSA, it's prostate specific antigen. So the levels of this particular protein is checked when you are diagnosing in a patient, and usually higher levels of PSA indicates the presence of prostate cancer. So here you can see that LINCAP VCAP has a lot of chromatin interactions happening in the KLK3, whereas DU145 and RWP have none. So this is an example, a very important and interesting example of how data integration plays an important role in giving you an explanation of why or what is happening at transcription level. So here I'm highlighting a KRT18 gene cluster. That is, these genes are expressed in prostate luminal epithelial cells. And this is an integration of ChIAPET data and ChIP-seq data. So ChIAPET gives you the interaction regions, and ChIP-seq will give you the binding sites of all the transcription factor and different proteins. On the right-hand side, I'm showing an integration of RNA-seq data as well. And here, this data clearly shows that there is an expression of only these two genes in the luminal cells, and though the subchromosomal region has different keratin genes as well. And the explanation part is that the RAD21 chromatin interactions are long-range interactions, which are insulating the these two genes and the enhancer to specifically express in the luminal cells. So that's how your integration data works in giving you a proper explanation of why things are happening. This is an AR gene region, and the region which I have highlighted is the AR enhancer. So by this integration on the left side and on the right side, there is a lot of interactions happening in the AR gene, and the region is the enhancer. So it's a high active enhancer, which is showing a interaction from enhancer to the AR gene promoter, and then it increases the expression of the gene. So that's how we deduced the conclusion that the enhancer is occupied by the AR and FOXA gene, which interacts with the AR promoter in the LINCAP and VCAP cell and increases its copy number. Finally, sorry, not finally, but there is still other data. So this is an example of how array-CGH data was used in clinical setting to evaluate the copy number status of androgen receptor gene and its enhancer. So 27 patient samples were taken. On the left-hand side, you can see a heat map, which highlights the enhancer region and the enhancer gene. And there are a lot of amplifications shown in dark red in the enhancer as well as the AR gene. And on the right-hand side down, you can see that there was a deletion which we found in the between the androgen enhancer and the gene, which brought the enhancer closer to the enhancer androgen receptor gene and increased its locus gene expression. So by this combining the data of ChIA-PET, ChIP-seq, RNA-seq, and also array-CGH in the clinical setting, it gives, it shows that AR locus amplification contributes to the transcription upregulation of AR gene by increasing the total number of chromatin interaction modules comprising the AR gene and its distal enhancer. Finally, I did some structural variant analysis also using the whole genome sequencing data of prostate cancer cell lines, LinkApp and DU145. LinkApp data on the left-hand side shows there are a lot of deletions and translocations throughout the chromosome. And on the right-hand side, DU145 cell line, it shows there are a lot of deletions and insertions in this particular cell line. So this structural variation analysis gave us the pattern of structural variations in two different cell lines, which can further be looked into and integrated into to see what the mutations or how mutation is affecting the 3D genome in general, what percentage it is affecting. And so finally, to summarize all the integration and what all information which we found after integration of different kinds of data is as follows. ChIA-PET, ChIP-seq, and RNA-seq gave us an explanation of why the expression of KRT8 gene cluster is unique to prostate luminal epithelial lineage. And that's because the RAD21 interactions, they insulate two genes and the enhancer. There is an active enhancer cluster which is located at 700 kb upstream of the AR promoter. And that region is also occupied by the transcription factors AR and FOXA1, which interacts with the AR promoter in LinkApp and VCAP cells. array-CGH gave us a lot of information about the copy number gains and losses in AR gene. And they also suggested that the enhancer alterations, they were more prevalent in the AR gene alterations in the MCRPC cohort. Whole genome sequencing suggests that LinkApp cell line has more translocations and deletions, whereas DU145 has more deletions and insertions. So with that, I would take a moment to acknowledge Michael Zhang lab at UT Dallas, my professor, Dr. Michael Zhang, who gave me an opportunity to work in his lab, Dr. Money, who is a professor at UT Southwestern Medical Center. So this project is in collaboration with his lab. I would like to thank him, Dr. Jiapen Yong, for helping me out in the analysis. And my lab members, and special thanks to Thao in the morning for giving me a shout out for my presentation. And with that, thank you for listening to me patiently. And if you have any questions, I would like to answer them.
Thank you for that presentation.
Thank you.
I think I see one question which says, are there implications for treatment from this?
Sorry?
Are there implications for treatment from this?
So right now, I am analyzing a data which involves some sort of drug treatment and looking into the changes in the chromatin and 3D chromatin interactions in the cell lines. But I hope that there will be some implications of drug treatment. So we are working on it, and there's a possibility that we will be getting some interesting results, which we can discuss further. But nothing for now as such.
Thank you.
I think there's one more question.
Yeah, no, it's not a question. It says thank you. Okay.
Okay.
There's one that says, I would love to hear about your integrated, I would love to hear about you integrated the data and tools you used.
Yes, there are different kinds of tools which I've used for different analysis. For the CHIAPET data, I've used CHIAPET version 2. For RNA-seq analysis, there's a big pipeline which involves mapping, and so Top Hat I have used, and expression analysis I have used Express, and for ChIP-seq I've used Max 2. Array-CGH I've used R package called as RCGH. Whole genome sequencing has I have used a lot of different tools for mapping the reads and calling the variations, and then I've merged it into a single file, and I've used that file. So I've used, for whole genome sequencing, I've used Delhi Lumpy, I have used CNVnator, and I think that's about it. So there are multiple tools which are involved in analyzing the data. So there are a lot of, there's a whole pipeline. So once the analyzed data is there, the files are integrated in IGV, and then you check the specific region to deduce what is the relevance or biological relevance you can get out of it.
All right, there is another question for you. It says,
sure. Can
structural variant analysis be used towards bacterial genome analysis?
So I'm not sure if I am the right person to answer this, because I have worked on human samples. But yeah, I think definitely you can use the tools to different kinds of tools to analyze the bacterial genome analysis. There are variety of structural variant analyzing tools for different kinds of genomes as well. So yeah, you can.
Okay. All right, thank you. If you have, okay, one quick one. It says,
sure.
EFT, can you tell us a little about your training to be able to complete this work?
So my training mostly involves a lot of literature review, and I have also used a lot of different tools which I used for this particular analysis in my previous projects. And mainly I had a senior whom I've mentioned in my acknowledgements also. So Dr. Jamey Jacob, she helped me in understanding the chromatin interaction parts. So I would suggest you to read a lot of papers and discussion forums as well, where how they have integrated. There are a lot of papers available on Google Scholar as well, where they have used a lot of integration tools also. So yeah, I mean, it's easy to just read papers, and in case if you need any help, you can always contact me. My email address is I hope you got that. Or if not, I can just give you my email address, and you can always contact me if you need any help.
Okay, and also if you have further questions, you could use Slack. You could ask the questions in Slack, and then
sure.
CADRE will be able to follow up with those questions. Thank you so much for that wonderful presentation.
All right, so it's appropriate that I'm following those two wonderful presentations from the medical field, because I'm going to talk about the agricultural domain, and we are at least 20 years behind the medical field in making our data interoperable. And so we're working on that, and that's what the ARDEN project addresses. So ARDEN is the Agricultural Research Data Network. So I'm working on this project with a lot of other institutions, which I'll cover a little bit later, but mainly the USDA National Agricultural Library. So this is a library project in many senses. So the problem that we're trying to address is that we're throwing away a gold mine. Researchers, and I'm talking about agricultural researchers, were mainly working in the with field crop experimental data. So typically a researcher will make a hypothesis and they'll design an experiment and go out and collect a bunch of data, make some great graphs and publish on it. And that's it. The data often disappear, or even when they're made accessible and findable on a repository, they're rarely made interoperable in any kind of way that is machine readable. So that's the area we're working in, is this portion of the FAIR data principles that deal with interoperability and reusability. So we recognize that these data have a huge amount of value, potentially, if they could be combined across experiments, across locations, across genetic material, across different managements, and new research could come out of those data. So, and again, back to the medical field, they've been doing this data interoperability in the medical field for a couple decades now. I realize they still have a long way to go there, but you can combine data from different clinical trials and get completely new research from those data. And we hope to be able to do that in the agricultural domain as well. And what I'm going to present, even though it's related to the agricultural domain, the problems are similar to other domains. And I think the solutions are portable as well. So we have a data supply on one hand, and we have a data demand on the other hand, and we're trying to bridge that gap. And some of the real challenges have to do that the data exists in different physical locations, different formats, definitely different vocabularies. There's no standardization, in other words. And so that's the gap we're trying to bridge with this project. So the project comes out of work that was done by the Agricultural Model Intercomparison and Improvement Project, AGMIP. There were some crop modeling protocols for multiple ensemble crop models. And because we wanted each of the models to have data in the same data, but each model had very different formats, we developed protocols that would supply the data to these models equivalently. So that's the basis for the work we're doing in Arden. But we've also worked with the CGIAR centers. These are the International Agricultural Research Centers. There's 15 of them around the world, but they have a unified data platform, big data platform called Guardian. And so we've implemented some of these data interoperability protocols on Guardian. The current project is working with the National Agricultural Library. And we've also done some work with the International Fertilizer Development Center to implement these protocols. So this is a huge effort with a lot of different players. So the elements of the solution, I'm going to list about 5 different parts of the solution that I think are sort of generic, that if you were to port this to a different domain, you would also go through these steps. The first 3 have to do with a hub and spoke system. So we have a harmonized data format that forms sort of the hub of this system. And we have data translation tools that allow us to bring data into that hub format and then out to the various formats. In this case, for AGMIP, it was the different crop models that all had very different formats. So this idea of the hub and spoke is very efficient because you don't need a translator from every source format to every end user format. You go through this hub, and it's a very efficient system for these types of data translation. And then actually, it's my first point. The glue that holds this whole thing together is this definition of a common vocabulary. And I'll come back to that later. So another element that was really important that we found in AGMIP was that if you want the system to be adopted, if you actually want people to use it and you want it to be useful, design it with input from the global community. And because we got input from all of these different groups, we feel like this is becoming an accepted standard. And my slides are moving on without me, but okay, so enough said about that. So even with the AgMIP protocols, we still had a major gap. So we've got sort of the end user side taken care of with the AgMIP translators, but we still don't have, or we didn't have a really good way to get data from these multiple source data sets in multiple repositories and so on over to that hub format. And so that's where Arden has been working. So Arden has, this is kind of a high level overview of what we're doing and the tool sets that we're providing in Arden. The AgMIP project, as I said before, kind of dealt with the end user side of things. So we've got these translators that goes from the hub format to these end user formats. Arden is more over on the data provider side. So getting data into that hub such that they can be useful to end users. So we end up now with these sort of 5 elements that you need to develop this data interoperability system. And I should add that if data are collected from the source in the correct way, that you don't really need to go through all of this. You know, in other words, if you collect your data with a known standard vocabulary or ontology, you don't need to translate it. It's already recognizable. But what we're dealing with here mainly is legacy data that has not been collected with a common vocabulary or a common format. So a lot of the times we go through that painful process of trying to resurrect those data sets. Okay, so I'm gonna drill down just a little bit to each of the those 5 elements that I identified. So the common vocabulary, when we started the AgMIP project, we already had a fully fledged hierarchical data dictionary for agronomic data. It had been developed by ICASA, which is the International Consortium for Agrosystems Applications. And it has something like, I'm gonna say 3,000 terms to define, you know, here I show some of the variables that can be measured in the field, in a field experiment, but it also covers things like weather data and soils data. So that's the environment part of it. Covers things like management, if you want to define a fertilizer application. So it's very detailed, and it was, you know, we had it at the start. So a lot of times in AgMIP, we joke about that we were building the plane while in flight. And so if we had not had this robust vocabulary to start with, it would have not been as successful. Ontologies, so I will mention that this is not an ontology, it's a hierarchical data dictionary. So there is some structure to it, but it doesn't have all of the sort of relationships that true ontology would have. But on the other hand, it's simpler to work with than these layers of ontologies to describe data. So I would not, I don't regret having made the decision to go with a data dictionary for our uses. The step 2, to design a harmonized data format. So this is sort of the hub. And I'm going to skip over this just for the sake of time, but just suffice it to say that it's a JSON, so it's a mostly non-relational format with key value pairs stored in a JSON object. Very efficient and flexible and easy to work with format. So this was part of the community of, you know, this global research community that came together to build this interoperability system. And we developed in a series of sprints or hackathons, these data translation libraries. And this particular one was at the Texas Advanced Computer Center in Austin. And it was organized by Steve Welch, who is our next speaker. So thank you for that, Steve. And so the final step, step 5, is to develop tools to help data providers make their data interoperable. And so Arden provides this protocol for doing this. And the protocol shows or provides a means of annotating data. So remember, these data sets may be in different physical locations. They are, using different vocabularies. They're in different formats and so on. But all of them, so in the case that we're working with the National Agricultural Library, they have a data portal called Ag Data Commons, which has its standard core metadata. And we are adding to that core metadata with these 3 sidecar files. So the first sidecar file, the variables are mapped to ontologies. So these are true ontologies, and we don't worry too much about units or any of the relational linkages, or even drilling down to the exact terminology. A term fertilizer might be good enough. But this allows the data to be discoverable through the semantic web. Where we're spending the most time is this sidecar file 2, which provides a very detailed roadmap for translation from the raw data format to AgMap format, so to that hub format. And so the raw data plus the sidecar file 2 can be interpreted in an automated way, and all of the data interpreted down to the units and everything to get to the AgMap format. And then from AgMap, you can get to all these end user formats. Sidecar file 3 provides searchable index data. So this is actually a subset of the data extracted from the data set, and it resides on Ag Data Commons, such that you can do very rapid advanced type searching without having to access the data, figure out what's in there. You can actually do that from the metadata on Ag Data Commons. This is a screenshot of the VMapper tool. This is a data provider tool. So they can take their data, which is in regular table formats, such as CSV, tab delimited, and Excel files. It has multi-table relational capabilities, but basically the user has walked through mapping each of their terms in their data to the Akasa variables. And there's ways of setting the relationships. It'll detect relationships, but the user can also control that. So there's a lot more to it. I think that this tool could easily be ported to other domains just by changing the data dictionary that it lies underneath it. And this is the product of VMapper. It's a sidecar file 2. I'm not going to go into any detail on that, but it's a JSON format, and it's got everything you need to know to understand what's in that data set. So now we have the tools. We've got a way to annotate the data. We know how to interpret the contents of the data sets in an automated way. We have translators that get us to AgMap, that hub format. We have AgMap translators that allow us to go out to end user formats. And so we've got all the protocols in place to be able to bridge that gap. And there are a lot of partners.
Sorry to interrupt. You have 1 minute more, please.
I am just about finished. So this is just saying some of our partners working with on the Arden project. There's a lot of people involved, a lot of data providers. And that is it. Thank you. Are there any questions? We might have a minute left to do questions.
Thank you, Cheryl. I think there is a question in the chat box.
Okay.
Will you know where this initiative is at for animal agricultural data?
Yeah, so the AgMap project and the Arden project are dealing with agronomic data. And just because that was our mandate from the start of the AgMap project, and because we've got this Akasa data dictionary that is specifically dealing with agronomic terms, But again, I think that if you had the vocabulary, you could take these same tools and same protocols and use it for the animal agricultural domain as well. Yeah, it hasn't been done, but I am very confident that it could be done. The hardest part is coming up with that vocabulary.
Thank you, Cheryl. I think that's all the time we have. So Cheryl, if you have something to add, I'm sorry we rushed you to finish your talk.
No problem. I was actually finished with my presentation. So of course I could go into much more detail, but I know we don't have time for that. But I did see a question from Jonathan about how to get involved. And so this is a 3-year project with, it's funded by USDA NIFA. And we are about halfway, a little bit more than halfway through our 2nd year. Year 3, which is coming up, is more about outreach and how we can get people involved and train more researchers into using these protocols. And so we will be holding data sprints where we get together. Hopefully it'll be actually in person. And we'll, you bring your data and we go through exactly how you would prepare it for the Arden network. And yeah, so I've written your name down and I can add you to my list of people to contact for next year.
I think there's a question for Cheryl. How do we motivate researchers to go the extra mile to supply their data using the tools you've developed?
Yeah, that's a great question. And there's always, there's carrots and sticks. And of course, the sticks are that a lot of funders are requiring researchers to make their data open and accessible. So far, they're not requiring data to be made interoperable, but I think that's coming. And so we're trying to provide the tools that allow that to be possible. The other, then there's the carrots part of it. And that is, that if you put your data out there and you can actually get citations for this. You can get credit for people using your data, either just by citing the paper or putting you on whatever publications come out of that. And there are loads of other carrots involved with it. But from what I've seen, younger researchers are eager to share their data and they want the tools to do it. And some older researchers who are nearing retirement don't, that's their data that they've collected over their careers is their legacy. And I'm seeing more and more that they like to share their data and they'll go that extra mile. It's that hump of researchers in the middle that, are still clinging to their data and afraid that people will abuse it or whatever. But I think the culture is changing.
I would go back and it's possible Cheryl's already answered this, but Phil did put in a slightly different question. It says, what is ARDN's perspective on incentives for researchers to use the tools and of course she was talking about carrots and sticks. So is there anything you want to add to that, Cheryl?
So next year, when we have the infrastructure, more robust than it is now, because we're still sort of in a development phase and it hasn't been implemented on Ag Data Commons yet. But we do want to hold these data sprints that researchers can come and make their data available. We don't really, provide any other incentive other than that. And I think there are plenty of researchers that do want to release their data. And like I said, that, some of the retirees are coming out of the woodwork saying, can we use this? Can we make, can we get in on this to make our data available? So I think, I guess that sort of answers it, probably not adequately, but yeah.
Phil, did you have any specific types of incentives in mind when you asked that?
Well, since I'm on the panel here, I can hop on. I guess what I was trying to figure out is whether in the conversations with the National Agricultural Library and some of the NIFA folks, if if they've mentioned anything about this becoming part of like project reporting or something like that, where it becomes part of your deliverable, is that you deliver data sets in a format or something like that. I mean, without some sort of enforcement, I wonder how much compliance there will actually be, or usage. I agree. I think there are a lot of us that want to share, and if we can make it easier for people to do that, then we'll do that. There are also quite a number of people, you know, that are, even if sort of they would sort of in their heart of hearts would like to, you know, it takes time, you know, and
I know it's hard.
And so obviously the tools that you're developing make it that much easier for people to be able to do it, at least for the agronomic type data that you're talking about. But I wonder about, without it becoming part of either requirements or some sort of incentive, like if there's been any talk with some of those folks about that issue.
So in the past, there really weren't, at least in our domain, in the agricultural research domain, there really weren't the tools to allow this kind of data interoperability. And so I think that, you know, that concept of requiring it just never really entered people's minds, because how in the world would you comply? Now, have we opened a Pandora's box that it's going to require, that now they're going to require everybody to use data interoperability tools? I haven't heard anybody say that, and I haven't suggested it either, but maybe that's what's coming.
But I guess I'm curious about why NAL is investing in this as an initiative if they don't have some plan for how they're going to get people to actually use it. I was curious if you had been privy to any of those kind of conversations and what the thoughts were about why or how it would be used. So, but yeah, that's okay. I actually did have another question.
So that it hasn't gone to that level of conversation yet. And the other part of it is that a lot of people who want data, like us, like crop modelers, they may go through the trouble of taking somebody else's data and bringing it through this process. It may not even be the data provider doing it, but we can, you know, we have the means now to store those artifacts from that process, so the next person doesn't have to do that. So yeah, but I don't know if this will become something that NIFA requires. I don't see that anytime soon.
Go ahead, Phil. Well, I was just going to ask, I didn't realize you weren't finished. I was going to ask if I could have permission to ask Cheryl a yes/no question, and in the process, demonstrate to everybody the importance of networking in this area.
So I'm sorry, what was the question?
I was asking our moderator if I could ask you a yes/no question.
Oh, I see. Okay.
Yeah, please go ahead, sir.
Okay, so Cheryl, there is genotype data in a data set that comprises some 80,000 genotypes. It's been assembled by CIMMYT. Phil and I have talked about getting metadata together on that data set and putting it into a standardized, you know, usable format. Sounds like a really good thing. Here's the yes or no question. Can we get together at some point, maybe when travel loosens up a little bit, and figure out how to do that?
Yes.
Okay.
And I'm going to add that, so Jeff White has been talking about the same thing, and we definitely need to explore that further.
Okay. Okay. So first, I'd like to thank on behalf of my co-authors, thank the organizers for the opportunity to be here. I'm going to be talking about work that we've been doing. Actually, it's a joint Oklahoma-Kansas project in wheat, just so that you all know why wheat is important. And that's because that 20% of all calories that are either directly or indirectly consumed by the human species come from wheat, okay? I had a great slide that, well, let's see, let's skip line here. Now, if you look at sort of demands due to wheat production versus the demands that would be needed to satisfy growing population levels, you see a gap there, okay? And I had a great slide as to why we ought to be scared about this. Actually, numbers like this, and wheat in particular, bear a significant impact on why we, in early 2011, the Syrian civil war started. But in the interest of time, I won't tell that story. Instead, I just want to focus in on our project. This is it here. It's an EPSCoR project involving these institutions supported by NSF. Its project aim is to increase the genetic, figure out how to increase the genetic gain of wheat through modeling and a number of other, and genetics and so forth. Even though it is genetic and modeling, and many of the things Phil Alderman talked about, Phil's on the project, what we're really aiming at here is helping to make sure that we don't have things like the Syrian civil war and unrest that's currently going on in sub-Saharan Africa and so forth, because when people get hungry, they get restive. Now, what I'm going to be talking about is a little bit the reverse of what some of the last few speakers talked about. They were aimed at, those talks were aimed at how do we get data. This is a little bit the reverse of that in the sense of how do we get people. And specifically, here shows sort of the size of our project, but if you compare these sets of numbers with that number, we've had difficulty recruiting students in a multidisciplinary environment. That's troublesome because it both impedes the research and it does not help you meet the workforce development gains that NSF sees as particularly important. And so what we decided to do was three of us, myself, Nora Bayo, who's also on this talk, and a mathematician, Nathan Albin, decided to offer a special problems course where we would both train students and have them do research. One of the benefits of that is, of course, is that you're not paying them, they're paying you, okay? And so how we recruited that course, this was started in the fall of 2019, was by posters that we posted in heavy traffic areas in colleges where people might come from. We were looking for people that were adventuresome, that wanted to do something out of the ordinary. That was what we called it. Now, and it was a special problem. First of all, I should ask, can everybody see my cursor okay? Yes, no? Yes, okay.
Yes,
good.
Yes, we can see it.
Okay, because I'm not using a laser pointer or anything. So anyway, people did see these posters, but actually what turned out to be most effective was word of mouth. I think that's because we had so many people on the project. This was our initial offering, although the one undergraduate that we had from our division of biology did drop the course after he found out sort of what the math emphasis was going to be. In the second semester that we operated it, these three women PhD graduate students continued on because they developed a real interest in the area during the fall. They really saw the opportunity to do interdisciplinary research. They enjoyed the first semester and they wanted to see what was going to happen. Now, there were some pros and cons to this I'll tell you about later. Yesterday, I was really, I really absorbed the visualization slides. I think it was Stephanie was her name, gave that talk. And so I've tried to overnight adapt at least a little bit of some of the things that she taught. You're going to see a lot of text here, but I want you to look more at the organization that's going to emerge here. What's on the left here is the topics that ahead of time we thought we would teach. And the way it was going to be organized is that the students would not only go through lectures but we'd have recitation sessions where they could work on various topics. However, what ended up happening is, it says AKA the best laid plans of mice and men, right? We were over ambitious, and what ended up happening is that these lectures started cutting into the work time for students. The red and the blue here is just to make reading a little bit easier if you're inclined to that. And of course, what happened is that COVID came along and that wiped out a lot of productivity as well, okay? But let me tell you two of the topics that we did get some significant progress on in these 2 semesters. In an earlier talk, Phil mentioned differential equation models, where you are trying to track some variables through time. Pretend you had 2 variables. Each little thin line you can see here is a plot of how 2 variables are changing through time. Now, the thing of it is, biology, the real world, is rife with variation. And so if you want to see what a distribution, a realistic distribution of the real world is doing, you have to run that model hundreds and hundreds of times and look at the envelope that results. There is, however, a technique called the escalator boxcar train, where it's automatic. You put in your model, and what happens is that you get out one equation that tracks for you what the mean of that cloud is going to do. You don't have to actually, it calculates the mean directly. And if you refine it a little bit, you can get out through time what's going to happen to the variation. Okay, that's one thing we worked on. Another is over in the statistical genetics area, where people use various statistical models, and they use Bayesian methods, and they use random samplers to trace out what is supposed to happen. Now, what we'd like a random sampler to do is to sample, what's going to be the major areas of the complicated probability distribution. So in short, we'd see something that would find where these concentrated areas are, stay with them, and just sample from those. There is a brand new method, reasonably new, called Hamiltonian Monte Carlo that uses, I'm sorry for the phone ringing in the background, uses statistical physics methods to try to stay in that concentrated area. The KSU Research Office just answered the phone for us, okay? Now, and so we wanted to compare that performance-wise. Now, again, I took some messages to heart from the visualization. Yesterday, you're going to see some slides, but I've gone back and color-coded them to borrow from Gordon Gekko. Green is good, red is bad, and black is important, okay? So here's sort of the standard scientific table of results, but I have color-coded it, and you notice that the standard sampler is green on these different statistical models. The HMC flavors that we ran are in red. Why is that? Well, if you look at sort of the minimum effective sample size of both these, that's like how many dots there were in those pictures I showed a minute ago. They're all about the same size. But on the other hand, if you look at how many of those dots were produced per second, then what you find is that you find anywhere from, a few tens to even hundreds of, a factor difference, okay? And what was happening is that statistical physics stuff takes a while to calculate, all right? Now, these are preliminary results. We still have tweaking to do and so forth, but at least in our hands, this is how this method has been working. Now, because this was such an educational experiment, we contracted with an external evaluator to do an evaluation of the course in spring 2020. Because of the small number of samples involved, students involved, they used a structured structured interview approach. Green is good. I'm not going to sit here and read these for you. I'll just flip through them. But you see, here's a black one. All the students felt better equipped for asking questions. That has got to be the heart of any interdisciplinary effort. People have to feel good about asking questions. They all learned, unfortunately, due to COVID, technologies for remote homework. There were some challenging areas, coding unfamiliar topics. Here's a big one, the non-traditional course structure. You'll see this reflected in some faculty issues too. It was an experiment and they would prefer us to pull it back more toward what they were used to, including, for example, a more detailed course description for prospective students and a couple of other points here, okay? There were some very positive outputs, technical progress in the areas we were trying to research. Students had abstracts or presentations accepted at 5 professional meetings. Okay, now one was canceled, that was accepted, but it was canceled. This was our annual project meeting. One was an international venue, and that one's available on YouTube. And SIAM, if you don't know that abbreviation, that's a big deal in applied mathematics, okay? And then 2 were at the same venue, which was a program that in particular was trying to advance underrepresented minorities in STEM areas. And so we felt particularly proud of those acceptances. There were some negative outputs, notice up here, not so much, okay? Our aim was that the Spring 20 efforts would yield a journal submission. Well, because of the ambitious fall outline and COVID, this did not happen. So we said, hey, well, we'll just give you incompletes for the course and come back, you know, in the fall and do it then for the incomplete. That did not happen either. Lost some momentum over the summer. This one I take particular responsibility for. One of the faculty members went off on sabbatical. There was other involvements, but in particular, I'm the overall project PI, and I just got sucked into other things and I did not pay attention. So this one, in large part, is my fault, okay? The students, though, had significant teaching duties. They were also reaching key points in their dissertation work. That didn't help, so they didn't get it done. So we said, hey, all right, you know, in for a penny, in for a pound. We'll just do this incomplete thing a second time. However, as Spring 21 began, the situation was untenable because, you know, we had one of the students was applying for a job, and here's this incomplete on our transcript.
Well, 1 minute more, please.
Okay, so we fixed it, okay? I'm gonna flip through these very fast. Here's the dues as seen by the students.
Steve, I'm gonna interrupt. Actually, our next speaker, in fact, the rest of our speakers aren't with us yet. So please don't feel you have to rush.
That's good news.
Oh, well, okay. See, black is important. But I still will go quickly in case they show up, okay? You know, these are all oriented toward making it more like a normal course, setting goals. They liked the multidisciplinary lectures. They wanted to make sure they saw how their tasks were applying to bigger aims and so forth. The do nots, there was one big one, okay? And that's understandable. Seen by the faculty, I'll let you read that one, but the key phrase here is don't do something like this the first semester of a multidisciplinary course because your faculty have to get their heads together on a, you know, on this multidisciplinary thing. We were fortunate that we were in that boat, but there's the real take home there. Planning, 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 including grading. There it is right up there. Can't emphasize that enough. Obtain departmental buy-in. This was all in math, but we had people from different departments. Cross lists so that the faculty are properly credited. We could have handled more students. Mix it up a little bit. Some short assignments with some longer ones, and those longer ones can produce abstracts that can be submitted later. Now here, if difficulties come up in the research, figure out what you're going to do from there on for that semester, replan, and involve the students in that as a joint student faculty team. Involve the students at every point. Research doesn't proceed smoothly, so they might as well learn what that's like. Here's two that we're seeing as important by the faculty. Set goals that are research oriented and advance everybody's development, not just the students, but also the faculty. And for those students where it's appropriate, discuss with them the possibility of extending course research into their graduate programs, because these two things can both help with what initiated the class, GRA recruitment problems and meeting workforce development aims. Do nots as seen by the faculty. Subsequent semesters are just not continuations of the preceding. They have to be planned. Do not fail to involve those student cohorts in planning the next semester. And here's one you've seen before. We learned, it was hard, but we learned, don't do that one, okay? And so I'd like to finish by, for all of us, expressing our gratitude for our sponsor, the other contributors. And in case I didn't mention it, this talk will also go, because they were so involved in putting it together, will all there, the first authors on this presentation. This will go on the CVs of those students that participated in that spring semester. Thank you all. And thanks, Kay, for a little bit extra time.
The question is, how may involvement be made with interested students in your project?
Let's see, we've got an echo. Are you asking in the project itself, or the 7 that I listed there? Or are you talking about in other venues associated with the project?
Maybe the person who asked the question could clarify. Oh, he said yes, the project itself.
Okay, so there was the ones that were in the course. I'm sorry where the echo is coming from. There was the ones in the course. There was the ones that are in several departments and several institutions that were in that total of 7. We have a couple of other projects. We have a Signals in the Soil project and a couple of others that are sensor related. There is some overlap in those. And so there are a few students that come in like that. He's not on today, but Franklin Fonjo, who's our Langston co-PI, talked about the other day about undergraduate students that he has in his, and that was the 15 undergraduates are involved through Langston. That's an undergraduate institution. He has a fabulous program there for involving and training undergraduates in these areas, and not in the context of our project, but in an earlier one that he had doing the same similar kind of thing. There was 3 of his undergraduates that designed and built an experiment that NASA subsequently flew in space. And so I cannot say enough about Langston and Dr. Fonjo's involvement with undergraduates, and that's benefited our project as well. I don't know if that answers the question, but I'll stop and see.
So Jonathan is asking, so do we connect with Dr. Fonjo? I don't know who the question is for, Stephen or Cheryl?
He doesn't have a box. Doesn't have a box showing. I don't know if he's one of the 33.
So he's asking you, Dr. Welsh, if he should connect with Dr. Fonjo.
If he's interested in this project and he's interested in really innovative undergraduates and how to involve them in research, absolutely, absolutely.
Okay, thank you.
Thank you for unmuting me. I'm so glad to be with all of you. I am an independent strategic planning and proposal development consultant. So the talk that we have for the next half hour or so, 25 minutes now, we'll be coming at the issue of data presentation that does not enter the category of black and white falsification or fabrication. We're coming at it from the way we tell our stories, the messages that, yes.
I apologize. Let me interrupt for just a second. Our next speaker hasn't signed in yet. You may have more time, but the official time allotment is 15 minutes, so.
Oh, goodness gracious.
Okay.
Let's get right into the PowerPoint. Let me start this, and I will share my slides, and I'd be very, very happy to have follow-up with people individually or as a group. But okay, please, Tay, I'm going to rely on you to keep me on target then. What I hope to cover in half an hour, and we'll try to compress it, are reinforcing the basic principles of logic and rhetoric and good writing that go into preparing any kind of sound, well-developed piece of writing, whether we're talking about a grant proposal or a manuscript or even less formal writing that is data-based. As you saw in the program description for this session, people are, even in general audiences, the general public, are more and more used to not trusting information unless it's either from a source that they're very familiar with or unless it's backed up by a lot of data. Unfortunately, we can see that data can be manipulated in ways that make it seem very convincing. And when we dig into it, especially people with a background in statistics or people who know the field very well, we find that data can be massaged and manipulated in ways that that are not always entirely ethical. We want to define that gray area, the area that we enter when we're trying to present data that was gathered soundly and according to the principles of the responsible conduct of research, but then amplified or presented in a hyperbolic way that is meant to be manipulative, that is meant to change minds with a very targeted focus, rather than what we might consider more sound and more ethical, which would be presenting the data and allowing readers or consumers of that data to reach their own conclusions. I hope that anyone who's who's participating now and who might use these slides later will use them as the basis to develop a personal strategy for applying professional discretion, building the confidence to know when we can take a strong position and back it up with what we know to be sound data, and do it in a way that is not manipulative, but in a way that shows strength and confidence. And I hope we can also have time to talk about the value of applying a qualitative overlay to quantitative conclusions that are data-based, so that the information that is gathered in the lab or information that is gathered by scientists and researchers who have devoted their careers to the study of a certain subject are able to present their data in a way that's well written and easily consumable by a general audience, what NSF and other funders think of as the broader impact. What we will not cover, and I've included here 2 screenshots in preparation for this session. I went out to my professional network, including several people who work for my company. One of them is a former program officer from 2 federal agencies. He played a role in developing some federal initiatives for grant programs. And particular to this case, he played a role in award management. And you'll see here that
Meg, I am so sorry, but we are not seeing your slides.
Oh, goodness gracious. Okay. I have shared my screen.
Yeah, I think your cell phone is connected. So.
I am also.
There you go.
Oh, there you go.
Okay. Okay. Let me start at the beginning and advance forward then. Thank you for letting me know that. I'm so sorry that we've run into this. Well, at any rate, whenever you see the responses, my question to my colleague was, could you give some, this is a serious conference that is based on research integrity. I said research integrity is at the very heart of the conference that I'm going to be participating in this week. And I went out with this request to several people, not all of them were former program officers, but this one in particular, when I said to him, we're looking for some light examples. We're not talking about fraud, we're not talking about intentional efforts to deceive, but do you have some examples of the awards you've managed where you've just had to grin because you've seen how hard someone has worked to make their case or to amplify their message based on data, stretched it or cherry picked it or any of the other things that we know people can do in an attempt to send a stronger message? And he got back to me so seriously and said, Meg, there is nothing to smile about here. This is, as you'll see, my colleagues and I do not find it funny when the Department of Justice gets involved. And if we had a little bit of back and forth, he was not willing to share any light examples because he was not willing to admit that there is a gray area. He has seen firsthand how the black and white issues can lead an institution to the front page of the Chronicle of Higher Education and can lead institutions to the point where they can no longer apply for federal awards. I thought that on the first day of this conference, there was a session on ORI, Don Underwood and CK's presentation, I thought was very, very compelling. I thought that they were talking about a very serious side of this, and they were able to do so with a lot of compassion. And my hope was that this session would be on the compassionate side. We understand why people are trying to tell their story as strongly as possible, but we've got to keep in mind that overlay of, there are serious black and white issues here. So to start, and I would encourage anyone who's on the line who is preparing to undertake an effort to communicate the results of your research or any other data-based communications for a general audience or for a scientific audience, revisit the basics each time. Anyone who's on your writing team probably knows this. Anyone who's a good writer in general probably knows all of these things, but revisiting, but just as, when you're asked to help a student with homework and you're revisiting fractions for the first time in a long time, it takes a little while for those wheels to get turning again. And I think that starting off with a reminder on a writing team of the basics of logic, the need to write with consistency and coherency to avoid contradictions and fallacies is critical. So is a reminder about rhetoric, how we write persuasively. We have a specific aim, whether it's for a grant proposal or not, whether the agency or whoever you're submitting your written draft to is requiring it, like with an NIH proposal, obviously you would have to lay out your specific aims and there's a specific strategy for that. But in general, you do need to have a specific aim behind any writing effort that you undertake. And you need to be sensitive to the audience and the circumstances. If you're writing about a hot button issue that is data-based, you can make your case. You can assemble all the data that's out there that is in support of whatever position you're advancing. But you need to be considerate of the fact that these are sensitive times. These are times when there are divides. There are big philosophical and political divides. And not everyone in your audience is going to be predisposed to taking your view. Showing sensitivity to the fact that there are both sides and a big continuum of middle ground is an important part of being a powerful storyteller. Considering the ethos and pathos, in addition to the logos, as researchers, focusing on the logical side, the proof of the matter is what we tend toward these days. Going back in ancient history, Aristotle would have said that the ethos, the ethics of it, and the feeling of what you're reading is just as important. So it's good at the beginning of a writing project, if you hope for it to have impact, to remind your peers that, that these three components go hand in hand. And do a refresher on semantics. You want to convey meaning. Semantics is the study of how we convey meaning, but then you want to attend to grammar and syntax and voice and style and these factors in writing that can make an enemy or an advocate of whoever is reading what you're producing. At the beginning of a writing project, if you hope to tell a strong story, you can make some presumptions and you can make some assumptions. So presumptions are based on some proof. We've got some background information that tells us you wouldn't be undertaking this unless you had good intentions. Your collaborators, we can presume they've got good intentions, or else you wouldn't have invited them onto your team. Speaking of a team, anything that you undertake as a writer is going to be stronger and more compelling if it is produced as part of a collaboration, because you'll want to have people on a writing team who are good writers, who are going to catch any grammatical errors, who can attend to the ethos and pathos in addition to, if you're the PI on a project and you're preparing a manuscript or a grant application or grant report. You're going to be attending to the logos. You're going to be attending to what you thought might happen, how you proved it, and how the data shows that. If you've got people on your team who can attend to other factors, you're much more likely to have a well-rounded document that you've produced. We can always presume that, more than that, we know that your writing project could always be strengthened and come closer to perfect if you had more time. And you can presume that you're fallible. We are specifically not talking about errors that are intentional. We are not talking about falsification or fabrication. Nonetheless, people who are well-meaning make mistakes all the time. Having multiple readers on your team who are part of a well-informed generalist audience and who are part of the research team and understand your field and discipline, those are the ways that we can make sure that whatever we're producing, which is always going to be more work than we expect it to be, and it's necessary work, we can make sure that when it does reach a broader audience, that it has a bigger impact, because we'll have lost no credibility along the way by making errors that were preventable. It's also, as much as we're assuming or presuming good intentions of the people we're writing with and the people in our professional network, this invisible person who's ultimately going to be reading whatever it is you're working on, we can make some assumptions about that person, not that they're true, and that's what an assumption means. We don't have proof of it yet, but we can assume some characteristics of them that, with these factors in mind, will encourage us to do a much better job, a much more proficient job of dotting our I's and crossing our T's if we think of them as natural skeptics. If you're writing for someone who's in your field, let's say a grant proposal, you know that when it's reviewed, it'll be reviewed by peer reviewers, people who are either in your field or have a similar level of education to you, people who have a similar level of expertise. And sometimes, just by virtue of human nature, when something comes through across our desk, we look at it, and if it's great, we think, why didn't I write that? I could have done that. Or we think I could have done a better job of that. So assuming that you've got some natural skeptics in the audience is a good driver of doing a good sound job of storytelling after we've gotten the research that's been conducted in an ethical way. So assume they'll be well informed. Assume that in every group of readers you might encounter, there are going to be some people who are naturally predisposed to advocating for your position. They're going to have a confirmation bias. If you're suggesting something, positing something that they already are prone to agreeing with, they're going to be looking for evidence and perhaps using the work that you've produced to bolster their own argument. So you will have people in the crowd who are predisposed to being an advocate for whatever position you're taking and using your data, incorporating it into their own body of knowledge. And in that way, we achieve broader impact. But you're also going to have people, now again, we're making the assumptions, but you're going to have natural enemies in that audience. You're going to have people who are, who take an entirely different position scientifically or philosophically. And if you write with it in mind that you've got some skeptics, some philosophical enemies in the audience, what it does is it drives you to anticipate whatever questions might be raised by a skeptic, and it helps you answer those questions. You anticipate what a skeptic will do to poke holes in your argument, what a skeptic will do to take a second and third look at your data and question the source and question your research methods. If you're assuming that that's happening on the tail end, on the consumption end, then on the production end, you're going to make sure you reduce those opportunities as much as possible. But keep in mind, your readers are fallible also. This is important because in storytelling, if we know that we've got fallible readers on the other side, if we make that assumption, it encourages us to tell a story in a way that is so compelling and build a case that is so tightly knit that it's very difficult to poke holes in. And in that way, making these assumptions of an audience that skews more negatively than your internal team of collaborators is a good driver for a good, strong effort. Now, this session was intended, again, to talk about the gray, not the black and white, but the zone in which you tell just a portion of the story. We know what data fishing is. To try to replicate a study over and over and over until finally, once we get something that confirms whatever our hypothesis was, we get some data results and we think, yes, we can finally use them. I'm finally proven correct. And then it's not replicated. Only telling that part of the story can be problematic. Sometimes it does fall into the category of black and white, unethical research misconduct. But often it falls into that gray area where we might disclose that that the results only went our way in one case, but we minimize that fact. Presenting one-sided arguments and especially using sources, whether they're primary or secondary sources, to support our arguments that don't have a lot of credibility or that are known to be partisan or known to, I'm thinking of research journals. Journals have their reputations, just as federal agencies or private sponsors have their reputation. If you have secured funding from a think tank that is known to be far to the left or far to the right, that kind of information and backing is going to follow you throughout future endeavors. So it's something to be conscious of. And it's something that if you're using those sources as the basis to bolster whatever argument you're making or whatever story you're telling in your written work, then you might be more likely to alienate at least half of your readers. Employing hyperbole is something I see so often as a federal peer reviewer. 9 proposals out of 10 are serving the neediest population in these United States. 9 proposals out of 10, or let's say 7 proposals out of 10 have come up with the best solution that's ever been created to serve that neediest population. That tends to put reviewers off. It tends to, from the start, if you're reading something very hyperbolic and you're sitting in a position of judgment, so if you are in a peer reviewer role, whether for a manuscript or an article or for a grant proposal, you can tell very quickly, just as you can as a general reader in the world. If you're reading a magazine article or a piece of fiction, you know very quickly whether you're in good hands, whether you can have confidence in the author right from the start and carry that assumption throughout the remainder of the written work. If you see errors early on, and if you see a lot of hyperbolic speech, it tends to convey a level of naivete that makes the reader feel that they might not be in good hands. It makes them read with more skepticism than they might otherwise. Likewise, prizing style over content can have the reverse effect. It can give you a lot of confidence in what you're reading and the person who has written it or the team that has written it. So if you're reading something that tells a really great story, it's doing it in a way that is stylish and that conveys an understanding of the audience and of the broader environment, and really carries you along in its flow. It might not dawn on you until much later that some of the data that's been presented is problematic. I have seen many times, there's one time in particular that I always come back to. It was the first federal peer review panel I was ever on for the US Department of Education, one of the federal TRIO programs. And this was at a time when they had 3 readers per panel. And the data that was required just was not presented. The Department of Education was asking for local, national, regional comparative data, and that wasn't presented in this case. We received something like, 70% of the students in the target population are at or below the poverty line, something like that. And it was for a program that had been in existence for decades. And because the story was told in such a compelling way, they must have had just an excellent grant writer working with them, or an excellent writer internally. But it was told in such a compelling way that it wasn't until you dug into that and looked point by point to what we were supposed to be evaluating on that we realized it just wasn't there. It was not a complete proposal because it didn't meet the guidelines in that way, and it deserved a score of 0 points in that category. But the great story writing or storytelling, it made such a champion out of one member of that 3-member panel that she fought and argued to the point that it got full points. Sometimes I think all of us have been in that position where you fight the good fight and try to stand up for the guidelines or whatever principle you're basing your opinion on and are outvoted. And that's what happened in that case. So a good, strong story can, for good or for bad, work in favor of whatever the thesis of the written piece of work is. I think it's a good idea to guard against entering that gray area right from the start. I don't know if all of you were on that Don Underwood presentation back at the beginning of the week or a few days ago, but there was actually, I better jump right into this. How are we on time, Kay? I'm realizing that we're like right at the end here.
Yeah, we are going to stop at 3:45, so you've got about 3 more minutes.
Okay, all right. So let me suggest that a pre-writing assessment allows us to, is a good strategy for guarding against any of the fluidity that could come, or the temptation that could come from entering that gray area, from deciding that you're going to tell a good, sound, compelling story at the expense of the facts, or at the expense of an unintended bias, advancing an unintended bias. And a couple of questions we can ask to do that are asking if you're qualified to write whatever it is you're undertaking, and if so, if you're the most qualified. Asking who your audience is and where you stand relative to them, of what career stage you're at, and why you're writing it, what your intentions are. The answers to these questions, especially if the answers to the first couple are that you're maybe early career, or you've just made a career transition, you might be on your guard. You might be in a position of being a little bit defensive, or a little bit fighting to make your mark in this world. And when you enter one of those cases, you might be more prone to prizing storytelling, prizing impact, amplifying the results of your data more than you would otherwise. Later career folks often have the confidence to say, my record speaks for itself. We had a good hypothesis. We proposed something innovative, and the data has shown A, B, and C. Reach your own conclusions. Whereas someone earlier in their career might feel that much more is riding on the results of this data. Kate, why don't I wrap up with this slide? But if I could, I will send the entire slide deck. I've included some references here, and what I was hoping that we could do, including with the audience, was go through some real world examples. I do have some of those that I'd be happy to.
Sorry to interrupt, we have 1 minute more.
I'd be happy to add some of those real world examples into the slides so that the slide deck will have the utility that we weren't able to build into this talk, unfortunately.
So my suggestion would be, I noticed you joined our Slack. workspace, and that would be a great place to upload your slides, or you can send them to me and I will make sure that they get shared.
Thanks, Tay.
All right. Thank you so much, Meg.
Thank you. I'm glad to connect
we
with
made
you.
it after all the challenges, right?
Yeah, right. I hope the rest of the conference goes just great. Really enjoyed it so far.
Yeah, thank you. Unfortunately, it's 3:45 and we don't have time for questions, but we have Slack. So if anyone has a question for Meg, please put it on Slack and she will respond to you. So thank you everyone for the wonderful presentations. And thank you all for the audience and for the great questions. It was quite an exciting session. I want to thank you very much, and I want to pass it on to Kay. Thank you.
Good afternoon, everyone. We're back here after we finished with the student spotlights. So we have received very good presentations for both technical sessions on interdisciplinary problem solving with data, as well as the student spotlight. So it was a tough decision to make. With that in mind, we have two winners. Allison Howard, with her presentation on using virtual reality to understand the effects of biophilic design on patients in 3D healthcare environments as the first prize. And Thao Bach and her colleagues as the runner-up with a presentation on correlative image analysis of the inter-morphogenetic domains, signaling networks regulating C, elegans, embryogenesis. Congratulations to both. We'll be in touch. Thank you very much. Okay.
Okay, well, this pretty much wraps it up. I'm going to share one more slide, basically as my thank you for everyone that helped pull this together. And assuming I've actually shared this slide because my Zoom controls disappeared. Hang on just a second. Try again. Going to share and expand. So thank you all for your participation. This has been a great experience, and we are so appreciative of the quality of the presentations and the wonderful information that you all have shared. And one quick thank you to those that worked to make it happen here, and the library and our Office of Research were the folks here at OSU that made this all come together. And then our sponsors listed there, OneNet, Dell Technologies, and Advanced Clustering Technologies are all were financial supporters. And the folks who served on the planning team are listed there, all of whom I think you probably saw today, except, well, at some point over the conference, except for one, and that is Nick Stevens, who is the guy who did all the work on the website. And I personally cannot thank him enough because he saved me unbelievable quantities of work. Frankly, I just couldn't have made it happen without him. So, so I'm just going to shout that out. And with that, okay, one other thing. You all will be receiving a survey, post-conference survey, and I will ask that you all take just a few minutes to fill it out because we will use your responses to help plan for next year. And we appreciate knowing what you liked and what you didn't like. So with that, thank you. Have a great weekend, and we will hopefully see you next year.